So welcome everyone to this webinar on Earth observation for hydrology in Africa. Many thanks for joining and for saying hello. So this webinar was made possible thanks to the collaborative efforts of the African Ministerial Conference on Meteorology, EUMETSAT, the EUMETSAT satellite application facility on support to operational hydrology and water management, HSAF, and EUMETSAT. My name is Anaël Cloarec. I work at EUMETSAT in Strategy, Communication and International Relations Division, and I will be hosting this event along with Marianne Diop-Canet, my colleague from EUMETSAT. So this webinar is divided into two sessions. The first session begins with introductory remarks with Marianne Diop-Canet and Paul Kounet from EUMETSAT. Next, we will hear from Olivier Kogels on water diplomacy, and then Sylvia Puka will present us an overview of hydrological products. After a Q&A, we will start a subsession about the use of satellite data for river basin monitoring. We will have a presentation from Georges Goulemvouka to speak about Congo River, and we will also receive Bashir Tanimoun from Niger Basin Authority. And the first session will end with a presentation from Zeleke Kebebushala, working at Nile Basin Initiative. We will then break until the next session starting at 12 UTC. The second session will be moderated by Marianne Diop-Canet from EUMETSAT. It will include a subsession focusing on flood early warning. And during the last hour of the webinar, speakers will give you practical information on how to access hydrological data. So we have a very exciting agenda. Thank you to all the speakers who will share their knowledge and experience. Thank you also to the interpreters. Indeed, interpretation in both English and French is available. To switch, you can just click on the world item at the bottom of your screen. You can either choose English, French or neutral if you are comfortable with both languages. Donc, une interprétation en anglais, français est proposée en direct. Pour cela, il vous suffit de cliquer sur le logo Terre en bas de votre écran. Vous pouvez choisir anglais, français ou neutre si vous êtes à l'aise avec les deux langues. So, without further talking, I am pleased to introduce our first distinguished guest, Marianne Diop-Canet from EUMETSAT Secretariat. So, Marianne, you have the floor.
Good morning. Thank you, Anaël. I'm switching off the video because of bandwidth. My bandwidth is very low. It's Marianne Diop-Canet, speaking from Addis Ababa, the WMO Regional Office for Africa, and also the African Ministerial Conference for Meteorology Secretariat. Good morning to all. So thank you so much, EUMETSAT, for organizing this very important webinar on Earth observation for hydrology in Africa to raise the awareness of users about satellite data and product for use in hydrology. This is a very important webinar, especially in this time where we are launching the early warning for all initiatives you're all aware of, and where we need to cover all citizens with early warning. This will be a significant input to derive early warning information to be disseminated to all users down to community level. I wish also to thank all participants for joining this virtual platform, which is now part of our working procedures. COVID-19 has been an evil, but at least has taught us something positive. We can reach a considerable number of people and train a lot, which we could not achieve years ago. This will be a good opportunity to strengthen the capacity of those in needs. So with that, I wish us all a very successful webinar. Thank you so much again. Over to you, Anayal.
Thank you very much, Marianne, for your opening speech. We will meet again this afternoon as you moderate the second session of the webinar. And our next distinguished guest is Paul Kounet, Head of Strategy, Communication and International Relations at EUMETSAT. So, Paul, the floor is yours.
Bonjour tout le monde et merci d'abord à tous les participants et puis merci aussi aux co-organisateurs, donc merci aux représentants d'AMCOMET d'avoir fait ce webinaire avec nous. Vous savez que l'Afrique est importante pour EUMETSAT. On a un satellite au-dessus de l'Afrique, on regarde l'Afrique mieux que l'Europe. Donc, il est vraiment important pour nous de développer toutes ces activités de communication, d'interaction avec la communauté d'utilisateurs avec l'Afrique. Et puis, aujourd'hui, nous avons deux thèmes. Donc, on a le thème de l'Afrique, mais on a aussi le thème de l'eau. Et l'eau, c'est un enjeu qui va au-delà de ce qu'on fait. C'est vraiment un enjeu stratégique, c'est vraiment un enjeu géopolitique. Et c'est pour ça qu'on a tenu, avant de commencer le webinaire sur les applications de l'hydrologie en Afrique, d'avoir un peu une présentation par le professeur Olivier Kogel sur ces enjeux géostratégiques de l'eau et de l'Afrique. C'est un spécialiste des deux, de l'eau et de l'Afrique. Donc, je pense que ça va être super passionnant, sa présentation. De notre côté, à EUMETSAT, on est en pleine période de déploiement de nouveaux systèmes d'observation pour la météorologie et pour le climat. MTG reste au-dessus de l'Afrique, donc vous continuez à être observé pendant les 20 prochaines années et nous avons un mandat au niveau de l'organisation pour s'assurer que d'une part, nos données arrivent en Afrique, arrivent vers tous les utilisateurs, les services météorologiques, au-delà des services météorologiques et qu'on puisse développer le plus d'applications possibles sur ces données qui seront distribuées gratuitement à tous les utilisateurs africains. Donc voilà un peu le contexte dans lequel on voulait faire ce webinaire. Et je ne veux pas prendre plus de temps, donc je te redonne la parole à Naël et bon séminaire, bon webinaire à tout le monde.
Merci beaucoup, Paul. So before we listen to Olivier Kogels that Paul introduced, I will just explain some logistics. So this webinar is live streamed on YouTube at this time and is being recorded. After the webinar is over, it will be available for watchover on EUMETSAT YouTube channel. We want to hear from you and have made Q&A chat available in Zoom. You can also use the classic chat to interact, but please write your questions in the Q&A chat. And during the Q&A sessions, we will give the speakers the opportunity to answer. So feel free to write your questions either in English or French. And if you want to ask your questions to a specific individual, please mark that person in the question. Please also note that the Zoom link is the same for both sessions. So this one and the one that will start at 12 UTC. I encourage you to use social media to advertise this event. You can use our official tag EU Africa. And we will now welcome Olivier Kogels, our first speaker, who will talk about international water diplomacy in Africa. So Olivier Kogels is an international expert in water management and diplomacy residing in Senegal. He devoted the last 25 years of his career to water diplomacy and to the management of transboundary water resources in dozens of countries in Africa and Asia. He has notably been the CEO of the Mekong Commission and advisor to several international organizations such as the World Bank and the European Commission. He is also emeritus professor at UC Louvain in Belgium and now devotes most of his time to the promotion and teaching of water diplomacy. Olivier, the floor is yours.
Thank you very much. And I will immediately switch to the application and share my screen. So there we go. Share. Will that be okay now? Okay. So, ladies and gentlemen, esteemed colleagues, I am truly grateful for this opportunity to embark with you on a very short journey through the issues and challenges of international water diplomacy in Africa. First, what do we understand by water diplomacy? Why do we need it? Water diplomacy may simply be defined as the application of diplomatic tools and strategies for water-related issues. It relates both to to surface and groundwater, and it involves state and non-state actors. It has also two dimensions. It can be local diplomacy or international diplomacy. Why do we need water diplomacy? Because water diplomacy is a common resource at various scales, various levels, from local to global, and because peaceful, effective, and sustainable use of and management of water needs cooperation, needs conflict prevention, needs conflict resolution. All this requires diplomacy. Mainly, the kind of diplomacy we have in related to water is a preventive diplomacy. We talk about, of course, the concept of conflict is at the center of our discussion. This graph is interesting because it shows how in the last decades, both the number of violent events between states and within states are dramatically increasing. However, it is well known that we don't have, in the past, we didn't have real violent conflicts between nations, but the past is the past and the future is maybe quite different in that perspective. And that's why we need this preventive diplomacy to avoid the conflicts which the risks are higher and higher. Our focus, my focus mainly also is international water diplomacy more than local water diplomacy. And that will also be the focus of this presentation. So it relates to what we call transboundary rivers, lakes, and aquifers. If we look at the world, there are around 300 transboundary basins. 153 countries share water with at least one other country, means most of countries, and that represents, let's say, 60% of the renewable water resources. How can international water diplomacy prevent and resolve water-related conflicts? This can be done through a range of diplomatic efforts made by states, by international organizations, and by non-state actors. It includes the negotiation of agreements and of joint declarations, the establishment of joint institutions, committees, etc., and the facilitation of dialogue and cooperation for joint investment planning, for coordinated operation of infrastructure, of existing infrastructure, for the monitoring of the hydrologic system and the environment, and I would add early warning, for data and information exchange. And early warning was included in my presentation already. To facilitate cooperation, a legal framework is being developed since many years at both the global level, regional level, and more basin-specific levels. At the global level, we have what we call the UN Watercourse Convention, which was signed in 1997. It entered into force quite late, only in 2014. And there are also a myriad of international accords tailored to regions or individual basins. One of them I have to mention is the Water Convention of the UNECE, which is basically a regional or basin convention in the beginning, but it's becoming global now. At regional and basin level, we have numerous and more, hundreds of regional or basin agreements, basin-specific agreements. And let's just remember that the first of these agreements dates back already to the 19th century to regulate the navigation on the Rhine. It is very important for diplomats to understand the origin of the conflicts. Why is there an issue between countries, and where is it coming from? The primary issue lies in what we call the spatial and temporal changes in water levels and discharges, such as we observe somewhere, someplace at some time, the changes in water levels in discharge as compared to what we consider normal. And this can be caused by seasonal shifts, by human activities, such as dam building, water diversions due to agriculture, deforestation, urbanizations, and of course, what is more and more on the radar now is climate change or climate variations. Tensions between countries arise from allegations of excessive water use, water withdrawals, extractions by one country that we believe is affecting others negatively, often because, most of the time because of dam building or because of large water diversions. And this happens mainly, of course, in water-scarce regions. And let us be aware that the number of water-scarce regions in the world is increasing very rapidly with population growth. So the changes in the water regime, the temporary and spatial changes, are really hard to understand and to predict. That's why a lot of issues are more dealing with perceptions than with reality. That is one of the big difficulties of water diplomacy. So there is a huge need to understand and to communicate about the variations or the changes in water availability. It is not easy, of course. So the tasks are to identify the root causes of changes and to anticipate what may be the impacts of those changes, both socioeconomic impact, environmental impact, and political impacts. And this is really at the heart of diplomacy. This is what we call really the bedrock of effective water diplomacy, the understanding and the communication about variations in water availability at some place, at some time, as compared to what we consider normal. The international negotiations need thus to be supported by hydrological modeling. This is absolutely essential. Real-time modeling, longer-term modeling, which is very, very complex if we want it to be accurate and reliable. It requires analysis and monitoring, including, and that's where EUMETSAT, of course, has a role to play, through space-based remote sensing. And the benefits of this monitoring and this modeling is, of course, informed decisions by policymakers and design of effective strategies. It also allows proactive responses to the challenges. Now, let's talk about international water diplomacy in Africa and see what are the main issues. 80% in this continent, 80% of renewable water resources are transboundary. And this is basically 66 transboundary rivers and lakes, you can see on the map, shared by at least 2 countries, and we know the Nile, 11 countries, the Niger, 9, the Zambezi, 8, and so many. But we also have transboundary aquifers, and examples are the Nubian sandstone aquifer and the Lulemeden aquifer shared by Mali, Niger, and Nigeria. Many of these aquifers are now being depleted at rates exceeding their natural recharge. So there is a lack also of clear governance structure leading to potential conflicts around aquifers. What are the efforts done so far in Africa? Since quite some time, I would say the beginning of the 20th century already, several countries have gradually implemented various cooperation mechanisms to manage and exploit their transboundary rivers and lakes. And there are about 20 international basin organizations that have been established, and many agreements have been signed. Some regions are a bit more advanced than others, and some basin organizations are robust now, some others are still very weak. Many basin organizations, and we have a number of representatives of basin organizations here, they know what I'm talking about. Many basin organizations face financial difficulties and they have many challenges ahead. Considerable efforts are still needed to strengthen existing institutions and to create new ones. And the main reason is a lack of political will at highest level. This is basically due to lack of awareness that only a collective approach can ensure not water management. Water management is not an objective, but collective approach is needed to ensure water security, energy security, and food security for people at a regional scale. This is really the basis of everything. If that is well understood by political leaders, the cooperation on water will certainly improve and institutions may be also strengthened. Now, the main issue in Africa is clearly population growth as compared to all other regions in the world. We know that this associated with socioeconomic development has a huge impact on very rapid increase of water demand and thus of water scarcity. This has substantial impact on the hydrological variability of water courses. And this is exacerbated by climate change. Now, a key issue is the need for significant increase in investment. Investment is really the core issue. Why? Because we still need a huge investment in water supply, in irrigation, in energy production, in protection against flooding. The funding gap and the investment gap for water-related infrastructure in Africa is huge. It's in tens of billions of even more US dollars per year. In sub-Saharan Africa, only 4% of arable land is developed for irrigation as compared to 20% globally. Only 1,300 large dams in the 50,000 existing large dams in the world are in Africa. This is only 3%. And the installed hydropower capacity is only 3% of the world total. This shows you the incredible investment gap in Africa, which you can see on the map of large dams in the world. The investment gap is obvious. Investment will thus continue. We like it, we don't like it, that is not the issue for a water diplomat. For a water diplomat, the key is to understand that investment in large-scale water-related infrastructure will just continue and accelerate for decades to come in Africa in all major rivers. The main issue will be the lack of coordination of those investments, and this will increase the risk of conflicts. This is the lack of coordination on the investment between countries and with all stakeholders involved in the impacts of large infrastructure. This is the lack of coordination, which is the key problem. An example we all know is the conflict between Egypt and Ethiopia on the Grand Ethiopian Renaissance Dam on the Blue Nile. So the equation is very simple. Population is growing dramatically in many regions in Africa. The water demand is thus increasing very quickly. Investment needs are growing and conflicts risks are growing as well. So as a conclusion, investment is clearly at the heart of water diplomacy in Africa. It is the main concern. The primary concern is avoiding conflict arising from large-scale investments in transboundary rivers. This requires negotiations of trade-offs. Trade-offs are essential between countries, but not only between countries, between economic sectors. That is also huge. The trade-offs between irrigation and hydropower, water supply, other activities, navigation, etc. This is what we call the nexus around water, energy, and food as related to large rivers. The negotiations more and more difficult as well, and also conflictual, is the trade-off which is required between production of economic goods to fight against poverty on the one hand, and the protection of ecosystems on the other hand. And this is also a huge concern and a huge origin of conflicts between sectors, between countries, between communities. So the key challenge is really what we can call meeting the needs, on the one hand, meeting the needs of economic growth and of poverty alleviation, and on the other hand, keeping the balance between countries, the balance between sectors, the balance between economy and environment. So the coordination of multi-sector investment at the basin scale is absolutely needed. Coordination of multi-sector investments, not only at the planning stage, but also at the operational stage when the infrastructure are operational and are existing. So for several years, I've been advocating for a stronger doctrine of cooperation, which I've called the doctrine of coordinated investment, but I have no time to go further into this here in this presentation. But to achieve this, broad access to accurate, reliable, and timely information on observed and also anticipated hydrological changes in both spatial and temporal dimensions are the key. And this is where such a seminar as today is so crucial. We thank you very much for your attention. If you want to know more about our water diplomacy training program, you can go to my website, which is simply my name. Thank you very much for your attention.
Thank you very much, Olivier. We could not start better the webinar. So if you have questions for Olivier, you can write them in the Q&A chat, and we will answer after the next presentation. But first, Olivier's presentation leads us to a first question that will permit us to know you, the audience, better. So the question is, what sector do you work in? You should see the poll on your screen. Donc, la question est, dans quel secteur vous travaillez? So we will have a look at the results after our next presentation. So yeah, next on the line is Sylvia Puka from HSAF, who will give us an overview of Earth observation projects in support to hydrology. Sylvia Puka works at the Natural Risk Management Office of the Italian Civil Protection Department on the operational use of the meteorological and hydrological projects derived by satellite data. She is project manager of the EUMETSAT satellite application facility on support to operational hydrology and water management, HSAF, and she is member of the NASA Precipitation Measurement Mission Science Team. So Sylvia, I'm looking forward to hearing your talk.
Thank you. Thank you, Anne, and good morning, everybody. Bonjour. I'm really glad to take part to this webinar today, I have to say. So I start to share my screen. Okay. May you see the presentation?
Yes, we see it. Thank you.
Okay. So today I'm trying to go. It's not working. I don't know why. Okay, in this way it's better. So today I will speak about the operational hydrological services needs, and we will see the main Earth observation missions related to these services. Of course, I can show only some of them. And we will see also some satellite-derived products and data that can help for international hydrological application. So unfortunately, as you know, due to the ongoing climate change, extreme events as flood, drought, and landslide are increasing, causing fatalities and significant economic damage every year. We see in Italy, and I'm sure that you have the same experience in your country. So several hydrological operational services are employed by national and international authorities in order to prevent hazards and natural disasters, as well to improve water management. So this service, to cope their mandate, need accurate and timely meteorological and, of course, hydrological parameter estimation we need in our institute, for example, at civil protection. And we need so the hydrological parameter as the one who reported precipitation, of course, soil moisture, snow, and also information about water resource, about the ground motion for the post event, and the estimation of river discharge. So we have to say that in the last 50 years, hundreds of satellites have been launched for Earth observation purposes. I report here only Earth observation mission from 2010 to 2030, operated by EUMETSAT and ESA. EUMETSAT and ESA have more than 10 missions in orbit with a lot of satellites, of course. Some of them are especially relevant, I have to say, to hydrology. So some are, for example, the EUMETSAT, MSG, and MTG now, and METOP that allow us with infrared, microwave, ASCAT sensor to estimate, for example, precipitation and soil moisture in near real time. Or we have instruments and satellites as ESMOS and Sentinel-1. ESMOS help us for the soil moisture measurement. Sentinel-1 on board we have SAR, very useful instruments for flood and landslide detection. We have also Sentinel-2, which is used often for flood delineation. So these are only the EUMETSAT and ESA satellite. But of course, there are other satellite organizations. For example, among the present NASA Earth Science mission, we have SMAP that help for soil moisture, GPM that we will see in some slide after for the precipitation estimation, and also other as ICESat that measure the elevation of a Earth surface. So we have to say that at present, we have a different sources of satellite monitoring system with different sensors that use different way to measure these hydrological parameters and provide information to us in near real time. So we have a lot of data. Now the question is why these data are so important. First, of course, satellite products can largely increase our monitoring capability, providing data continuously updated on regular grid on a wide area. And this is very important for our operational purposes because we can be confident that we have data with a regular delivery and with an accurate also estimation. This is we can view, for example, also the data over other countries or over ocean, and this can help us for early warning when the severe event, for example, meteorological event is coming from other countries or is coming from ocean. So this is EUMETView, and this is a very useful tool for an update and view of the precipitation and other parameters. So second, studies show a strong decline of in situ observation networks in Africa region as well in European ones. So in the future, this data will be even more important than now. And this is important, so to start to introduce right now. Third, we have to say that the satellite high-resolution data can see processes that we are not able to model. One of these is the irrigation, of course. So we have seen that we have a many satellite systems with different instruments on board. Now we can see which product make use of this data. And we start with precipitation. because, as you know, this is a key crucial to feed the first hydrological model and consequently the hydraulic model. We have several products for the precipitation estimation. I selected the ones can be used for operational purposes and that we use in our institute. One of these is the EUMETSAT product of global precipitation measurement of NASA and JAXA. EUMETSAT provides the rain rate at global scale every 30 minutes with a special sampling of 0.1 degree. But we have also the EUMETSAT HSAF precipitation products. So the first one shows the rain rate estimation. This is available with 0.05 degree, so it's a very accurate product with high spatial resolution. And the revisit time is 15 minutes. So we daily use these products to monitor the meteorological event as severe storms. Then we have also in EUMETSAT accumulated precipitation products. One is the one reported in the middle is accumulated that it is provided 1 hour accumulated precipitation and 24-hour accumulated precipitation with a special resolution of 0.05 degree, and it is available every hour. And the last on the right is the daily cumulated precipitation, and this is available with a special resolution 0.25 degree every day. So different cumulated products for different application. For first of all, of course, for hydrological model as hydrological model input. But also, for example, long time series for the estimation of the anomaly. It is important to stress that the EUMETSAT HSAF products are developed for operational purposes and so are continuously validated by several international teams to certificate, we can say, the accuracy, latency, and data integrity. This is, for example, the validation which is ongoing on Sub-Saharan Africa using TAMO network. Of course, this is one of the networks that is used for validation of precipitation, but there are many other ground networks used in different parts of the world to test the accuracy of these products in a different region of the world. Another important parameter is soil moisture. The evaluation of soil moisture is really important as input first of the hydrological model, as for the evaluation of the antecedent condition for hydrological risk forecast. We use in our institute also for this, or for drought estimation. So we have surface soil moisture and soil water index products in Copernicus services. They are delivered with different spatial resolution, and they refers to the first centimeters of the ground. We have also the EUMETSAT HSAF products at surface soil moisture. So also in this case, we have information in the first centimeters of the ground, and this is available with different spatial resolution, 1 kilometer and 12 kilometer. That's depend on the kind of application that you have in mind. And it is available every day, of course. The second product, the EUMETSAT HSAF root zone soil moisture, provides soil moisture from the first centimeter to 3 meters under the ground. So this is able and very useful for our modeling application. So I have to say that all these products are available in near time, but long time series are also available for both EUMETSAT HSAF and also from Copernicus services. So about the remote sensing for snow, I don't want to dedicate so much time to this aspect. So we have the snow water equivalent in the land service, the global land service of Copernicus, and we have a product for snow cover and snow water equivalent also in the EUMETSAT HSAF. So about the remote sensing for flood detection, we have seen which are the main parameters that we can have from satellite data. But we need to have information not only during the event and to forecast the events, but also after the event. So the post-event analysis is very important for the decision maker to understand how we have to operate in very short time. So about remote sensing for flood detection, I would like to introduce Copernicus Emergency Management Service, which uses a satellite imagery and, of course, others data, geospatial data, to provide mapping service in cases of natural disaster, as I said, floods, landslide, severe storms, earthquake, and many others. So CHEMS provides maps during all phases of the emergency management cycle and produce two temporal maps in two temporal modes as rapid mapping, so very close to the event, or in risk and recovery mapping mode that will provide after a long period or not so short period many other information related to the event. So here, for example, I reported the delineation map of the flood occurred in October 2020 in Togo on the Oti River, and Sentinel-1 and Sentinel-2 were used for this delineation map. And also I report the map on the right that show the flood damage rate in the area of Zimbabwe. The map has been derived from post-event satellite image, in particular spot 6 and Pleiade, and in yellow is used for possible damage. So in very quick time after the event, we can have a delineation and grading map to understand what we have to do and what happens, of course. So CHEMS provide mappings also for ground motion analysis and landslide delineation risk. Here there is an example related to an event occurred in Ischia, Italy, and different sources of satellite were used, as you can see. Unfortunately, we have a lot of natural risks, so one of these is the landslide. So last but of course not least, in the last years we had the first studies on the estimation and forecast of the river discharge using satellite data in fact for flood forecasting activities and hydraulic risk mitigation. We need accurate and timely estimation of river discharge. About the forecast, the idea is that the observation acquired some days before at an upstream section is informative of the downstream discharge. So by using the information acquired by satellite at an upstream section, the river discharge at the downstream section can be assessed for a forecast of some days. So we are still at research phase, but I have to say that the results are really promising. So to what we have now? Now we have the possibility to have the estimation using satellite data of the main hydrological parameters, precipitation, soil moisture, snow, and snow water equivalent. These are available in near real time for early warning purposes, for example, but also as long-time series for analysis of the anomalies of the soil moisture, the precipitation, and so on. So the data access is very easy. We have this data by FTP or by web, and the EUMETSAT products also by EUMETCAST. It's also very easy to have a visualization in near real time of all these parameters. These are completely full operational and tested every day from international group for certificate the accuracy. We have also the possibility to monitor the post events of floods and landslides using, for example, the emergency rapid mapping of Copernicus. And also this is completely operational and tested for many years. About river discharge, we start to have the estimation of river discharge and some application for the forecast. So this is still in research phase. So that's all. We have all these products. The data services are, of course, free and available. I really hope that they can help you to advance understanding of Earth's water cycle, helping your institute to cope your mandate, as it is, for example, in my institute, Italian Civil Protection. Thank you.
Thank you very much, Sylvia, for this overview. Sorry. If you want more information on the projects mentioned, this afternoon we will hear presentations focusing on different projects Sylvia presented. And now that you had time to answer to the poll, let's have a look at the results. So the results seem to be very well balanced between research education, hydrology, and meteorology climate, which is great, as I am sure the information provided during the webinar will be useful for you. And thank you again for answering and for attending the webinar. So we have already listened to two very interesting speeches, and I see we already have many questions from the audience. So we are going to start our first Q&A session. In case we don't have the time to take all the questions, the panelists will try to answer writing in the chat. So first question, could you elaborate a bit on the GERD conflict? I am particularly interested in data availability to make science-based negotiation. This one is from Amin Shakia. So can you answer to this one, Olivier, please?
Yes, you bring me in one of the most difficult issues and most, of course, key one in water diplomacy in maybe the whole world. It's really difficult to give an advice here because so many ideas are around. But first of all, I think we should put aside the legal aspects. This is my vision since the beginning of the conflict. I was involved in the discussions with the NBI on the creation of the Nile Basin Commission if the agreement would have been passed in the 2010, and it didn't happen. I think now it's time to, it has, the only way is to have a pragmatic approach, and I think a way may be out, and I've been already expressed this at high level in 2015. The three countries, Egypt, Sudan, and Ethiopia, have to think in terms of a common goal, which is just having the willingness to achieve commonly one goal, which is increased food, energy, and water security of the three countries in a negotiated approach. And so taking a bit of a helicopter view, a little bit of distance, seeing the GRD in the more broader scope as being one of the contributions to this water, energy, and food security. But the awareness has to be at the highest level, heads of states level. The willingness has to be at heads of state level. It happens in the Senegal River 30 years ago, when heads of states came together to say, we cannot fight alone on desertification and drought. We have to do it together. So I think that is the starting point. And then we see in how joint operation, coordinated operation of the existing dams can be achieved in a peaceful way. Maybe this is wishful thinking, of course, but I don't see any other way out. Thank you.
Thank you very much, Olivier. We have another question for you from Ali Idris. Can you give a brief overview over how coordinated investments be realized? Precisely on what level should it be initiated and sustained?
It is a bit along what I said just before. To achieve coordinated coordination, there must be the political will at highest level. And to have political will at highest level, there are a number of ingredients. The issue to be highlighted is poverty alleviation, economic development, investment for water security, energy security. That should be the language. That's the first basis. The second thing is that we need what we call a program approach. One common program, and not 20 programs and projects and all kind of terms and terminology used for design that nobody understands anymore. What we need is at the highest level, I mean, heads of state level, the agreement that together we will put together a joint multi-sector investment program, to achieve commonly together water, energy, and food security for our people. And that we give this program a very easy name, that we use the media, we use high-level communication. This has to be shared by the people of the countries. This is a common goal. There is no other way. And on that basis, we can coordinate infrastructure development and infrastructure operation. This is my way of thinking. Unfortunately, I see that many basin organizations, they started basin planning, etc., but there is a dilution of efforts. There are too many terms, too many different projects and programs, and the visibility is not enough. So first reaction, increase the visibility of the common goal at the highest level and share with the population of the country.
Thank you very much, Olivier. Now we have a question for Sylvia from Emmanuel Nuiki Ponki Jung. Sorry for my pronunciation. The question is, can we have satellite observed data on river discharge? If so, what are the sources and their accessibility?
So the data that are used for river discharge are radar altimetry and near-infrared sensors also. As I said before, this is a research activity. So some colleagues that will have tomorrow a presentation of Italian National Center of Research is involved in this kind of research. So if you want also, I can send you some information about this. You can contact me directly by email. So, but this is the data that I use from satellite data point of view. And this is only research, so that I cannot say that we have operational in some project.
Thank you, Sylvia. This question makes a great transition to our next subsession on river basin authorities. And this afternoon, we will also have a presentation focusing more on this topic. So we have to end the first Q&A session. Thank you for both the questions and the answers that were very interesting. We will now welcome our first speaker for this subsession, which is Georges Goulemvouga. Georges Goulemvouga serves as Director of Water at the International Commission of the Congo-Ubangi-Sangha Basin, CICOS. Prior to joining CICOS, he served as the Technical Manager at the Waterways Management Agency, DRC. He has extensive experience in the field of hydrometry, hydrological modeling, and management of regional projects. So, Georges, the floor is yours.
Thank you. Thank you, Anaël. I'm just preparing my presentation. Just 1 second. I think my screen is
Yes.
Okay. Thank you. As presented by Anael, I'm George, working for SICOS. Our presentation will be on inland navigation as a downstream product used or elaborated using the spatial data. So the outline of our presentation have 6 points. The context, we will give the service we are doing with the spatial data, the new tools of the water management and the natural resources management in Central African region using the geoservices, the subsequent action, the services impacts, and we will end by a short conclusion. Donc, comme nous le savons en termes de contexte, le bassin du Congo ou la région, elle est connue comme le second, elle était connue pendant plusieurs années comme le second poumon de la planète. Mais nous nous rappellerons que lors de l'après-COP scientifique, on a déclaré ces bassins comme les premiers, étant donné que l'Amazone devenait de plus en plus le problème par rapport au bassin du Congo qui séquestre mieux et de manière avantageuse les gaz à effet de serre. Donc, dans cette même région, nous rencontrons plusieurs cours d'eau qui sont pratiquement des boulevards naturels, évalués à plus de 25 000 km, qui se trouvent être l'élément important pour booster l'économie de la région en termes de voies de communication. Et nous voyons dans cette région qu'il y a aussi plusieurs pays qui sont enclavés et qui sont désenclavés que par le voie d'eau. C'est une région également qui renferme un potentiel important, évalué à plus de 150 000 MW, dont 44 sont situés au barrage d'Inga, et avec d'immenses surfaces de forêt, donc évaluées à plus de 5 millions de kilomètres carrés. Et il se trouve être également la région où se trouvent des forêts inondées et à évaluer à 46% pour les bassins du Congo en lui seul. En termes de voies navigables qui concernent notre thématique ici, donc on a plus de 2 millions de tonnes évacuées par voie d'eau, avec plus de 2500 bateaux sur l'ensemble de ces voies. Et le transport fluvial se trouve être le transport 10 fois moins cher que d'autres modes de transport. Et c'est un mode de transport plus utilisé qui permet les échanges des hommes et de marchandises dans la région. Donc, depuis plusieurs années, avec l'appui des partenaires, la SICOS et les pays membres, donc la SICOS qui est en charge de la gestion, de la promotion de la gestion intégrée des ressources en eau et de la promotion de la navigation intérieure, avec l'appui de plusieurs partenaires, dont l'Union européenne, l'Union africaine et d'autres, la coopération française et la coopération allemande, a mis plusieurs projets dans le sens d'améliorer ce secteur de la voie, de la promotion de voies navigables, de transport fluvial. Et tout récemment, nous sommes engagés dans un grand, vaste programme africain, GMS Africa, dans sa deuxième phase, où nous avons pratiquement l'ensemble des pays de l'Afrique centrale, le Burundi, Cameroun, Centrafrique, Congo, RDC, Gabon, Guinée équatoriale, Sao Tomé et Tchad, qui sont bénéficiaires de ces projets, de ces programmes au niveau de la région de l'Afrique centrale, à travers un consortium de plusieurs partenaires, donc dans la région. Nous avons OSPAC pour la surveillance des forêts de l'Afrique centrale, la Commission du bassin du lac Tchad, le Centre de recherche en eau et du changement climatique, l'Université de Kinshasa, ICOMA et d'autres associés pour développer des services afin de booster ces secteurs de la navigation. Donc, 3 services majeurs sont en train d'être mis en œuvre. On a commencé avec d'autres initiatives comme AMSD, MESA et maintenant c'est GMS. Et l'accent en ce qui nous concerne pour ce webinaire, c'est le suivi d'une hauteur d'eau pour la navigation intérieure. Donc, avec cette phase, nous voudrions améliorer davantage les produits élaborés pour les utilisateurs finaux en termes de géoservices pour permettre l'accessibilité facile de ces produits aux bénéficiaires finaux. Donc, les besoins ont été identifiés. Les difficultés, c'est que les niveaux d'eau ne sont pas connus. Nous rappellerons que la navigation n'est possible qu'en connaissant les tirants d'eau, d'abord, et le chargement doit tenir compte de ces tirants d'eau. Il y a plusieurs passes où il y a des écueils qui limitent la navigation. Donc, il fallait voir comment, avec les données que nous avons, les données Landsat Sentinelle de l'altimétrie spatiale aujourd'hui, avec l'attente des sautes qui venaient d'être lancées en décembre dernier, élaborer des produits, des services qui pouvaient aider les utilisateurs finaux, les navigants. Donc, nous avons à ce jour, déjà avec des initiatives passées avant GMS, élaboré des bulletins de prévision à horizon de 5 jours, 10 jours, qui sont lancés aux capitaines et qui leur permettent de charger leurs bateaux afin qu'il n'y ait pas rupture lors de la navigation. Mais aussi, tous ces produits ont été mis en format smartphone, toujours dans les besoins de faciliter l'accessibilité. Donc, nous avons les données, comme je le disais tout à l'heure, optiques de Sentinelle-2, qui sont capables également, au-delà de l'aspect navigation, nous avons également les suivis de la qualité de l'eau et aussi les suivis des faits et l'utilisation des sols dans la région. Nous avons également des données compilées pour déterminer tout ce qui est le chaînon de cours d'eau, afin de permettre à mieux élaborer des routes de navigation. Donc, les bénéficiaires finaux sont un grand spectre, les utilisateurs de l'eau de manière générale, et par rapport aux produits qui sont de la navigation, bien sûr, c'est les navigants, mais aussi les décideurs. Ils sont en train de manager ces secteurs importants pour la région. Donc, l'idée globale, c'est de fournir ces services afin de soutenir sur les différents formats, bulletins, rapports. Et maintenant, nous avons inclus les web plateformes, donc une plateforme web qui doit fournir des géoservices et plusieurs géoservices sur les suivis d'inondations, sur les hauteurs d'eau pour les besoins de la navigation, suivi des forêts et autres. Donc, les premiers produits ont été, cartes de navigation ont été mis sous le format des smartphones, donc comme nous le voyons en image, accessible à travers ces téléphones. Le capitaine peut bien suivre la route et de navigation qui a été tracée, voir les bouées avec beaucoup de facilité. L'innovation actuelle comme nouveau outil mis, c'est cette plateforme que nous appelons GERNAC, gestion de l'eau et des ressources naturelles de la région Afrique centrale, qui doit encore améliorer l'accessibilité et la visibilité de ces produits liés à la navigation. Donc, les réseaux premiers que nous avons pris en compte, c'est le fleuve Congo, le Kasaï, son premier affluent, l'Ubangi, le deuxième affluent, la Sanga, mais ça peut être reproduit également sur d'autres cours d'eau. Donc, les hauteurs d'eau sont suivies donc, grâce aux données de la télémétrie spatiale. Donc, nous avons des stations virtuelles avec les premières missions Jason 2 en EUMETSAT. Nous n'avions pas autant de stations. Aujourd'hui, c'est dans le 1000 et quelques stations virtuelles que nous avons, les différentes missions lancées que nous sommes en train d'exploiter et que, comme nous disions tout à l'heure, soit va encore révolutionner l'accessibilité aux champs parce que les informations, nous les aurons même sur les cours d'eau de faible largeur qui n'était pas possible pour d'autres missions passées. Et ceci, nous déployons des séries temporelles qui nous permettent de réaliser des prédictions utiles pour orienter les navigants. Donc, il y a également des données radar qui permettent, comme je le disais tout à l'heure, de définir les chaînons de navigation, mais également les bancs de sable, parce que la dégradation qui s'opère sur les différents versants du bassin du Congo, et le résultat, c'est qu'il y a augmentation de la sédimentation dans les talwegs où se trouvent les cours d'eau, et ça limite de temps en temps la navigation, les tirants d'eau nécessaires pour la navigation. Mais également le végétaux envahissants qui souvent bloquent la navigation. Donc, ces données nous permettent également de les suivre et les localiser. Avec cette approche également des géoservices, nous sommes en train de les mettre sur le format smartphone également. Tout ça, c'est créer l'accessibilité, diffuser les données les produits également ou ces services sous forme de bulletins où les bénéficiaires finaux y accèdent et les utilisent facilement. Mais tous ces produits élaborés, bien sûr, ce que nous visons grâce aux données spatiales utilisées, c'est pour soutenir le bénéficiaire finaux de ces secteurs, donc qui a besoin de la sensibilisation des actions de sensibilisation que nous menons, afin que les données soient utilisées, mais que nous ayons également les feedbacks nécessaires pour les améliorations de ces produits. Déjà, les impacts positifs reçus, il y a eu amélioration de la navigation en termes de sécurité, donc réduction des temps de voyage, parce que beaucoup de bateaux en certains points sections qui faisaient les ruptures de charge, qui traînaient parce que les tirants d'eau n'étaient pas accessibles, ou de temps en temps qui échouaient sur les bancs de sable, ont vu, grâce aux produits émis, ont vu leur activité, les temps de voyage réduits et leur activité améliorée en termes de la production, mais également l'amélioration de manière globale des échanges dans les zones de production qui sont l'intérieur de plusieurs agglomérations et ces agglomérations, mais également dans tous ces processus, ce qui est visé, c'est le développement de l'économie bleue dans la région Afrique centrale. Donc, là, en termes de conclusion, nous pouvons dire que les ressources en eau sont de la région. De manière générale, les ressources naturelles se trouvent être la fondation même du développement de l'économie bleue. Et les données de l'observation de la Terre sont nécessaires, surtout pour connaître ces données, parce qu'on gère mieux que ce qu'on connaît avec les réseaux faibles au terrain d'observation des stations in situ. les données d'observation de la Terre jouent un grand rôle dans notre vaste bassin, notre vaste région. Et les géoservices développés et en cours de développement vont encore améliorer ces secteurs pour le développement socio-économique de la région. Je vous remercie.
Merci beaucoup pour la présentation. We will now hand the mic to Bashir Tanimoun. So after serving for some years at the Ministry of Hydraulics and Sanitation of Niger Republic, he has been working for over 18 years in the field of water resources management and assessment at the Niger Basin Authority, known as ABN, specialized in hydroclimate database processing and management, hydrological analysis and forecasting. Since 2015, Bashir Tanimoun was appointed as regional coordinator of the project Satellite-Based Water Monitoring and Flood Forecasting System in the Niger Basin, SAT-NBA. Bashir, you have the floor.
Hello. Hello.
Hello, we can see your presentation and we hear you.
Merci beaucoup. Bonjour à tout le monde. Donc, effectivement, je voudrais présenter les outils de connaissance et de coopération dans le cadre d'une coopération autour du bassin du Niger. D'abord, je dois présenter le bassin du Niger, c'est-à-dire l'autorité du bassin du Niger. Le bassin du Niger, il est là, c'est un fleuve qui a l'ordre de 4200 km sur une superficie versante de près de 1,5 million de kilomètres carrés. C'est 9 États, l'autorité du bassin du Niger, à savoir le Burkina, le Bénin, le Burkina, le Cameroun, la Côte d'Ivoire, la Guinée, le Mali, le Niger, le Nigeria et le Tchad. Avec une population de plus de 160 millions d'âmes. Et l'autorité du bassin du Niger est créée depuis 1964 pour faire de la coopération autour de cette ressource partagée dans le bassin. La mission de l'autorité du bassin du Niger, c'est la promotion de la coopération entre les États et assurer un développement intégré dans le domaine de l'hydraulique, l'énergie, l'agriculture, etc. Les enjeux dans ce bassin, c'est, entre autres, un fort taux démographique qui est de l'ordre de 3% dans certains pays du bassin, la sécurité alimentaire, la sécurité énergétique, le changement climatique et également la paix. La sécurité est devenue un fléau dans le Sahel que nous sommes en train de juguler et d'essayer de travailler dans ce sens. Ils ont comme conséquence, c'est-à-dire l'accroissement des besoins en eau, la tendance à la baisse de cette eau, la variabilité climatique et les potentiels risques de conflits autour des usages sur cette ressource. Le bassin du Niger est vulnérable aux catastrophes naturelles, en particulier les catastrophes météorologiques et hydrologiques, à savoir les sécheresses, les inondations, les tempêtes, les températures excessives, l'érosion et l'ensablement dans le bassin qui découle comme conséquence, c'est-à-dire l'état des écoulements du fleuve Niger et ses affluents. D'où la nécessité de réduire les impacts liés au changement climatique, améliorer la résilience de la population face au changement climatique et essayer d'impliquer également tous les acteurs dans la gestion durable des ressources en eau pour assurer une cohérence, c'est-à-dire dans les aménagements et les planifications autour de ce bassin. Pour ce faire, l'autorité du bassin du Niger a développé un certain nombre d'outils pour essayer vraiment d'accompagner, c'est-à-dire les actions et le rôle que les États membres lui ont confiés. Donc, on a mis en place un certain nombre d'outils de modélisation, à savoir le modèle d'allocation de ressources en eau, qui prend en charge, c'est-à-dire tous les besoins et les prélèvements des États, et également, il nous permet de faire la planification sur l'utilisation de cette ressource et également les mises en œuvre de projets au niveau des États. Mais à cela, il s'assoit sur un réseau hydrographique composé de 105 stations hydrométriques qui sont suivies et partagées par les États. Et à ce faire, nous avons développé un certain nombre d'outils, tels que les outils de modélisation pour la prévision hydrologique, mais également des outils pour la gestion coordonnée des barrages. Vous savez, on a un certain nombre de barrages sur le cours principal et les affluents, d'où la nécessité de développer un outil qui va permettre la gestion efficace des différents réservoirs pour essayer vraiment de respecter, c'est-à-dire de répondre aux différents besoins en aval de ces différents ouvrages. Il y a également, nous avons développé un outil, un système d'information hydrologique qui permet de donner un certain nombre d'informations et de produits qui sont diffusés sur les différents sites web de l'ABN, mais également partagés au niveau des différents acteurs clés qui sont identifiés, à savoir les structures focales nationales, les coordinations nationales des usagers et usagères sur le bassin du Niger, les différentes agences de gestion des barrages, des offices d'irrigation, mais également les différentes collectivités pour qu'ils prennent connaissance de l'état de cette ressource au niveau du bassin. Et également, nous avons développé des systèmes d'alerte précoce, surtout sur les inondations et les sécheresses, à partir de ces stations et également la base de données régionale qui est opérationnelle au niveau de l'ABN, mais également un certain nombre de canaux pour la diffusion de ces informations, à savoir les FTP, les sites web qui sont développés au niveau de l'ABN pour partager au mieux, diffuser ces informations au niveau des différents utilisateurs. Ces modèles, nous avons des modèles de tendance de propagation, des modèles pluie-débit, mais également des modèles élaborés à partir de l'altimétrie spatiale. Et les horizons sont de court terme, de moyen terme et de long terme, donc de 5 jours à 6 mois que nous élaborons ces informations et diffusées pour les bonnes prises de décision. Donc, il faut reconnaître, à travers tout ce qu'on est en train de faire, il y a des difficultés, il y a également matière de penser à apporter des solutions. Et c'est pour cela qu'au vu d'un certain nombre de difficultés, que ce soit des difficultés liées à l'opérationnalisation ou bien le fonctionnement des stations qui sont installées sur le terrain au niveau des États membres, l'inaccessibilité de ces stations d'observation pour la collecte de données, et également le manque de données et de leur qualité suite à l'insécurité qui sévit dans le Sahel. Donc, nous assistons à une forte détérioration du réseau d'observation et une dégradation de la qualité des données, avec des manques de données fiables en temps réel pour faire des prévisions au niveau et également faire certains suivis au niveau du bassin. D'où la nécessité pour l'ABN de développer de nouvelles alternatives pour assurer la collecte de données hydrologiques et socio-économiques, lui permettant de jouer son rôle dans la gestion durable et efficace des ressources naturelles dans le bassin. Et c'est à cela que l'ABN, depuis 2013, s'est lancé sur l'utilisation des données satellitaires pour l'élaboration de produits et informations pour accompagner la planification et également pour éclairer les prises de décision. Donc, nous avons mis en place avec l'aide d'un certain nombre de partenaires, c'est-à-dire à savoir le Royaume des Pays-Bas, la Banque africaine de développement, nous avons développé ce projet qui s'appelle le projet Hydrologie satellitaire dans le bassin du Niger. Et ce projet, dont je vais présenter brièvement un certain nombre d'acquis et des résultats acquis dans le cadre de la mise en œuvre de ce projet, mais également, en plus de ça, nous nous sommes lancés depuis 2016 sur une initiative avec un certain nombre de partenaires, avec l'IRD, le CNES, pour le développement du suivi hydrologique par l'altimétrie spatiale dans le bassin du Niger. Donc, au niveau du premier projet, c'est-à-dire à savoir le projet mis en place avec la collaboration d'un certain nombre de partenaires, que ce soit du Pays-Bas, donc les données EUMETSAT sont les données de source pour le développement de tous les produits découlés et des outils développés dans le cadre de ce projet. Donc, c'est un projet qui a permis de mettre en place, c'est-à-dire un certain nombre de modèles, à savoir les modèles climatiques et les modèles hydrologiques, pour faire de la prévision hydrologique, mais également pour diffuser les informations liées à
Bashir, I think your sound is not working. Can you hear me? Can you hear me, Bashir? I think Bashir is struggling with his connection, but we can go to our next presentation, and Bashir will be able to continue after. So before Zeleke Chala's presentation, we are going to ask you another question. So I am launching the poll. So the question is, at which scale hydrology matters for you? Donc, à quelle échelle êtes-vous intéressé par l'hydrologie? I let you around 15 minutes to answer. And during this time, we will hear Zeleke Chala's presentation. So Zeleke is an Earth observation expert. Oh, maybe Bashir is back. Great. So you can continue, Bashir. Can you hear me, Bashir? Bashir, can you hear me? Your mic is muted.
Allô?
Oui, je vous entends.
Allô?
Oui, vous m'entendez?
Je m'excuse, ça s'est coupé, c'est l'Internet, donc vraiment c'est la situation, il faut essayer de comprendre. Donc, je vais essayer de faire vite pour finir. Donc, je disais bien qu'il y a un certain nombre de produits que nous mettons à la disposition, que ce soit des chercheurs, que ce soit des utilisateurs, pour vraiment essayer de partager les informations par rapport à l'état du bassin. Donc, il y a également un site web qui est www.sat.abn.ne qui est développé et opérationnel pour le partage des informations avec les différents utilisateurs. Couplé à ça, il y a également un site FTP qui permet de faire les échanges avec les États, avec les différents utilisateurs, que ce soit les services météorologiques, les services hydrologiques, mais également les agences de réduction des risques et catastrophes, pour pouvoir faire le downscaling au niveau de leurs différents États. Donc, avec ça c'est un exemple de la situation de 2020. 2020 était une année toute particulière au niveau du Niger, qui a causé pas mal d'inondations au niveau de la ville de la capitale Niamey, mais également, nous, on a eu à informer, à déclencher cette alerte au niveau de Niamey qui a permis la réduction d'un certain nombre de catastrophes au niveau des biens et également au niveau des vies humaines. Donc, à travers cette initiative que nous avons mis en place avec nos partenaires hollandais, mais également dans le cadre du souci de recherche d'autres informations ou bien d'autres sources de données pour essayer vraiment de corréler ou bien de mieux valider ce qu'on est en train de faire, nous sommes lancés avec nos partenaires du côté français, avec l'IRD et le CNES pour l'altimétrie spatiale, c'est-à-dire dans le bassin du Niger. Et à travers ça également, un outil est en train d'être développé pour essayer de faire les alertes. Ici, c'est les alertes de 1 mois, d'horizon 1 mois, à partir de l'altimétrie, de données altimétriques. C'est-à-dire, à ce niveau, nous avons essayé de développer un outil qui s'appelle le modèle hydrologique MGB, Niger, qui fait du suivi de la ressource en eau à travers les données altimétriques, mais également, couplé à ça, on a développé des outils de prévision pour donner de l'information également anticipée sur les événements extrêmes au niveau du bassin. Donc, ici, c'est les différents résultats, mais également à ce niveau, nous avons développé des plateformes web qui permettent l'accessibilité de ces informations au niveau des différents utilisateurs qui sont identifiés dans les États. Donc, il y a eu également des renforcements des capacités, que ce soit au niveau des experts de l'ABN pour pouvoir s'approprier de cette technologie qui est en train d'être mise en place au niveau de l'ABN avec ses différents partenaires et également au niveau des États à travers un certain nombre de suivis terrain pour le calage et validation de ces informations. Donc, dans le cadre de cette initiative, nous avons eu à accompagner les différents États en termes d'équipement hydrologique, d'équipement de collecte de données à travers les stations de la télétransmission au niveau des États qui ont été installés sur des points stratégiques pour essayer vraiment de mettre à disposition ces informations. Cependant, ces stations sont sujettes à un certain nombre de défis, que ce soit des défis en termes de disponibilité de l'Internet, mais également des défis sécuritaires qui fait que nous faisons face à un certain nombre vraiment de challenges qui doivent être relevés. Donc, les perspectives en termes pour le bassin, c'est la mise en place et l'opérationnalisation d'un mécanisme de financement durable. Le financement est très important. C'est un sujet que la première présentation sur le mode de la diplomatie sur les ressources en eau avait bien évoqué qu'il faut qu'il y ait un mécanisme de financement, que ce soit au niveau régional, mais également au niveau des États. La poursuite de renforcement technique et la modernisation du réseau d'observation hydrométéorologique, le développement des technologies innovantes comme nouvelle alternative pour le suivi hydrologique, tel que le satellite aujourd'hui, qui est depuis une dizaine d'années, est devenu vraiment une source ou bien un moyen, une alternative dans le cadre du suivi hydrologique pour nos bassins et également pour nos États. Il y a l'amélioration de la communication entre les différents usagers des données, c'est très important. Il faudrait accentuer sur ce volet et essayer également d'apporter un certain nombre d'améliorations à ce niveau. Et enfin, la facilitation d'accès des produits et données d'information aux différents utilisateurs à travers les différents canaux de communication, également les différentes plateformes qu'on doit essayer de mettre en place, surtout au niveau régional, mais également au niveau continental. D'où, pour conclure, je dois dire qu'il faut promouvoir la synergie de travail entre les différents acteurs, que ce soit au niveau régional, au niveau national, mais également au niveau continental en termes de production et de diffusion de l'information pour une gestion durable et une meilleure maîtrise des phénomènes hydroclimatiques dans le continent. Je vous remercie.
Merci beaucoup, Bachir. Merci pour la présentation. So let's now have a look at the results of the poll. You seem to be mostly interested by country level, but also regional and water basin authority, which is great as it is exactly the theme of this subsession. To continue focusing on this scale, we will now welcome Zeleke Shala. So Zeleke is an Earth observation expert at Nile Basin Initiative, nicknamed NBI. Welcome, Zeleke. I give you the floor.
Okay, and thank you. Thank you for the opportunity to speak on this webinar. The topic I'm going to talk on is just Earth observation to support the mandate of the Nile Basin Initiative. This is the content of my presentation. The Nile Basin. So the Nile Basin, the river Nile is the longest river in the world. It is 6,695 kilometers. Area of the basin is 3.2 million square kilometer, which is 10% of the continent of Africa. The basin is shared by 11 countries. Nile Basin is characterized by high climate diversity and variability, uneven distribution of water resources, high evaporation rates, and the basin is also vulnerable to drought and climate change. The Nile Basin Initiative. Nile Basin Initiative is an intergovernmental partnership led by 10 countries: Burundi, Democratic Republic of Congo, Egypt, Ethiopia, Kenya, Rwanda, South Sudan, Tanzania, and Uganda. And Eritrea is an observer. Nile Basin is guided by shared vision, objective, the objective okay. It's shared, Nile Basin is guided by shared vision objective. The objective is just to achieve sustainable socio-economic development through equitable utilization of and the benefits from the common basin water resources. The core function of Nile Basin is cooperation, water resource management, water resource development. Nile Basin Initiative has 3 offices at 3 different locations. One in Uganda, in Entebbe, second in Addis Ababa, Ethiopia, and third in Kigali, Rwanda. Nile Basin has 10 years strategy, which is implemented through 5 years programs. And the program focuses on 6 thematic areas, which is aligned with SGD, and which is water security, energy security, food security, environmental sustainability, climate change adaptation, and the transboundary water governance. So when I come to my main topic, EO data to support NBI, NBI uses Earth observation data to support its mandate. One of the core mandate of The Nile Basin is to support transboundary water resources, resources management through analytics, modeling work, knowledge, policy, to provide support to water resource management to countries. To mention some of our projects that utilizes EO data are, example, data and analytics service platform. This platform is under development. It is almost dependent on publicly available Earth observation data, like data from EUMETSAT, drought monitoring and early warning portal. This portal also utilizes Earth observation data majorly. We have other projects also like groundwater, wetland project. In this project, we utilize Earth observation data mainly, as Earth observation is our main data source. The quarterly basin monitoring bulletin. Also, we use almost 100% Earth observation data to develop our basin monitoring bulletin, and this presentation is focusing on that. We have also other research projects like radar altimetry, which is sponsored by EO Africa, EO Africa, and that research project is in collaboration with Twente University. The Nile Basin Monitoring Bulletin is one of Nile Basin knowledge or information products, and the bulletin is 100% based on EO data. The bulletin is released every 3 months and disseminated to stakeholders. The content of our basin monitoring bulletin is one is rainfall. The rainfall data is coming from trips, and we use the monthly data from WAPOR or FuseNet portals sometimes. And the actual vapor transpiration interception, this is also from WAPOR, but somehow we bias correct the evapotranspiration data at Nile Basin using observed data. Runoff, this is one of our bulletin components. This is one of the things we are monitoring at Nile Basin. It is based on rainfall and evapotranspiration and interception. Water level is, it's computed from Johnson and 1 and 2, and just we are downloading this data from the website from EPAD. When I come to the EUMETCAST receiver, the EUMETCAST receiver station was installed in 2022 with a fund secured from World Bank. We have to install the station only, otherwise the data is free. We got the license for free from EUMETSAT, and the objective was just to enhance data and information service at Nile Basin. So we use the EUMETCAST data to, we are in the process of automating EUMETCAST receiver data. The objective is just to improve the content of our basin monitoring bulletin, and to improve also the content of our knowledge products. So what we do is, what our plan is just to want to automate the data we are receiving, the products. So this product is part 3 will be linked to our basin monitoring bulletin. We use also EUMETSAT satellite for another purpose. The recently established Nile Basin Initiative Regional Hydromet Monitoring System leveraged on the EUMETSAT satellite data transmission system to data site management system. There are also other, we have, yes, we have other portals also, like the drought monitoring portal. This portal utilizes Earth observation data. It's automated, and from the portal, we automatically also generate bulletin, drought monitoring bulletin, bi-weekly, sometimes monthly. So from the portal, it's possible to download, generate and download graphs and different other charts, maps, and as well as the monthly bulletin. So anyone can go to nilebasin.org to see and to use this portal. Where another portal is Nile Basin, the forecast and the monitoring. We have flood forecast and early warning system also. We have river flow forecast system. Also, this portal utilizes Earth observation data partly. Challenges we have when there is awareness about satellite data or about Earth observation data and its importance, but there is a limited capacity to use the data, like which data is for what, which tool to use, and how. And these are some of the challenges we have within the basin. Thank you very much.
Thank you very much for your presentation. We will now go through the Q&A. So you can still ask your question in the Q&A chat, and we will try to answer some live and the other writing. So first question is for Georges. And the question is from Jesse Arnold Chila Nkwabong, sorry. S'il vous plaît, pouvez-vous expliquer comment les stations virtuelles sont-elles utilisées?
Ah oui, ça c'est l'ensemble de connaissances qu'il faut, c'est les longs processus, mais déjà par rapport aux données, quand ils sont captés, il y a plusieurs plateformes aujourd'hui qui enregistrent toutes ces données. Nous avons Hydroweb d'Haïti et plusieurs que le CNES avec Lagos est en train de fournir. Mais sinon, la station virtuelle, c'est par définition, c'est le croisement de la trace du satellite avec le cours d'eau. Et il y a plusieurs algorithmes qui sont élaborés ou logiciels où nous mettons ces croisements de la trace avec le cours d'eau et nous dépouillons pour obtenir les hauteurs d'eau fournies par, ou les signaux fournis par les passages de satellites. Et c'est plusieurs satellites. Nous avons commencé avec Jason en EUMETSAT et aujourd'hui, c'est Sentinel qui nous offre ces données d'altimétrie spatiale, donc à travers ces stations, et en attente des SWOT qui va encore révolutionner, comme je le disais tout à l'heure. Donc, c'est le croisement. La station, d'abord, elle doit être compris que c'est le croisement de la trace du satellite avec le cours d'eau En cette section, les algorithmes sont utilisés pour obtenir les hauteurs d'eau. Donc, on peut discuter avec les collègues qui posent la question en off, où nous pouvons fournir plusieurs informations. Merci.
D'accord, merci beaucoup. So now a question for Bashir. If your connection is okay, Bashir, can you answer to the question from Oda Saran? Can you explain more about early water system in floods?
Oui, je ne sais pas si je dois dire ça en anglais. The early warning system that we are implemented here in Niger. In fact, it is we have developed some models, about 2 models. The runoff model, which is taking the ground data to simulate by propagation to give what is going to be at the station downstream. And coupled with it, we have established some satellite information system for flood forecasting. That's the one that I explained, which is using EUMETSAT data to take the rainfall, to simulate it into runoff and make the forecast of about 6 days terms. And also we did with the arithmetic data, we developed a tool, which is, we are calling it MGV for Niger, which is using arithmetic data, the one that Mr. George talked about. They are using it for monitoring the water level to do the navigation, while here at Niger Basin, we are using it to develop the forecast in flood forecasting in the Niger Basin. It is the same people that we are collaborating with them at SECOS and also at Niger Basin, but the idea it is some diverted into the 2 area of hydrology. That's the meaning that we, and also as I said, we are sharing. I think we are sharing our contact. You can contact us and we can give you more detail about it. Thank you.
Thank you very much, Bashir. We will also have a session on flood early warning this afternoon. So if you're interested, you will learn more during this session. Now, a question for Zeleke. You will use the new data from EUMETSAT instead of old data sets in NBI. Can you answer this one, Zeleke, please?
Yes, please. Thank you. Yeah. We use yes, definitely we use EUMETSAT data, but we cannot totally also depend on EUMETSAT data. Absolutely, we use data also from other sources as a complementary. Now we use in EUMETSAT data, we are interested in the near real time data, and like the soil moisture and etc. But we cannot totally depend on EUMETSAT only. But definitely we will use new data from EUMETSAT data. Thank you.
Thank you, Zeleke. Another question for you from Anya Kamel. So the question is, what type of forecasting model do you apply, and do you make a calibration on such a model?
For example, for flow forecasting system, we use mic operation software. For flood and droughts, we use DHI's food in the droughts system. that's it. So for a detailed explanation, I think you can go to also the site and see how the model is developed and what data is utilized, used, and what models are used, how we bias correct the data, and etc. It is well elaborated on the portal. Thank you.
Thank you, Zelike. We are going to end our Q&A session here, but you can still read the answers in the answer tab in Zoom, and the answers will be published on EUMETSAT page 2. So if you're interested, the answer will remain available. If some of the speakers want to say something to end the session, you have the floor. Otherwise, we will see you this afternoon. So thank you very much to all the attendees. Thank you to the speakers. We are going to have a break until 12 UTC. So thank you again to the panelists. Your presentations were excellent. I was very excited to see them all. Thank you to everybody for attending, and the discussion is not over. So if you would like to continue to exchange on this topic, you can use social medias, and we will be back again this afternoon. So thank you very much.
Thank you.
Thank you.
Thank you.
Thank you very much.
Welcome again, everyone. Thank you for joining this afternoon session. I will give the mic to Marianne Diop-Canet, my colleague from AmConnect, who will moderate this afternoon session. Marianne, can you hear me?
Yes, good afternoon. Welcome all to this second part of the session. I hope you had a good lunch. So I will be looking in this afternoon into the data access and their usage. So it's going to be in two parts. The first one for 1 hour to look into floods early warning, and the second part onto the access of Earth observation, hydrological data, and knowledge. So I will introduce the first speaker, Ganyu Ishola Agbaje, who is a lead scientist on Earth observation. And he is currently the lead of flood services in GMS. So Ganyu, you have the floor and you have 10 minutes.
Yeah, let me see if I can unmute myself. Good afternoon.
Good afternoon, Gania. We can hear you. You can go ahead.
Okay, you're hearing me?
Yeah.
Are you hearing me?
Yes.
Okay,
go
great.
ahead to present
Thank
the
you very
flood
much. Good
monitoring
afternoon.
in West Africa.
Thank you. Well, I'll be presenting a project which uses Earth observation for. Hello. Hello.
Hi, Gania. We can hear you.
Okay.
You can proceed.
Okay. Right. I'm using I'm presenting a project which is under the GMS in Africa, an initiative of the African Union Commission and the European Union Commission. We use Earth observation data for flood monitoring and assessment, which is, hope you are seeing my screen there. I hope you're getting my screen.
Yes, we are getting it and we are hearing you.
Thank you very much. So it was actually developed during the first phase of GMS in Africa. And it was carried out by 7 institutions in Africa, in West Africa, and across 5 countries. The areas, the data, where we get the data we use for the project, the methodology used, the indicators for flood modeling, where are the ingredients we use for the modeling, the result of flood risk model, so will be generated, then mention some of the training workshops carried out for the DMOs, the challenges, and the future plan. What we have done is to develop an hybrid flood risk modeling approach using ECRAS and GIS models. We use GIS technology to map the risk areas in the study areas, which are mainly river basins, because we are dealing with riverine flood prediction. We present a new approach for mapping and flooding the flood risk. The aim, actually, of the project, MIFMAS, is now to enhance the efficiency of flood monitoring and assessment by mandated organizations, the DMOs, so that they can now introduce the use of Earth observation into their services. And at the same time, we use the opportunity to boost their human capacity to adapt to these developed services. The conceptual framework is such that we believe in the past flood event database, use it along with the predictive model, which we develop, and come up with an early warning decision. And the information can be sent through MSS via the internet, using your smartphones, and also using the laptops or computers. We all know that the major approaches to flood modeling is using hydraulic flood modeling, integrated flood modeling, or modeling using GIS and remote sensing, but there are weaknesses in both of them. The hydraulic modeling has a tendency, the high probability of under-predicting, and the integrated modeling, the high tendency to over-predict. We use now the strength of both to combine it to develop a robust modeling approach. The study areas, as I said, are around the river basins in Côte d'Ivoire, the district of Abidjan, Comet Basin in Benin, Ogunshu River Basin, but we specifically zone down to Mana River Basin in Nigeria, Ghana, the Black Volta, and Burkina Faso, Bobo, the Alazo, and Burkina Faso, and the Volta Basin. That is the location in Nigeria. There is within the southwest part of the country. The closest and the most popular town there is Ibadan. And that's just the data we use and where we got it from as displays on the table. The Allos-Parsa Sentinel-1 data, them data, mainly the soil data, the land use data, electrical structural data, rainfall data, and Sentinel-2, we are able to collect a lot of spectral images. We develop a script to harvest identify satellite images needed for the 5 countries from Copernicus and USGS GLORIS. And precipitation data were also obtained from mandated organizations in the country, and where there are gaps, we use the soil and water assessment tool SWAT. Well, these are the list of things we can use. I mean, you need the data you need for across modeling, using the across model, flood, high resolution digital elevation model, soil data, land cover, shapefile of the urban areas, and hydrographic data, and precipitation data. This is an example of what we call the flood event database, which we use for validation. We're able to get some data, information from 2011 to 2021 to look at the occurrences of flood. The flood hazard inventory layer, which we are looking at there, is how it affected the communities based on the event database, which we had there. This was created using the Google geocode algorithm, and we later use it to validate the flood risk model. These are the various special layers created for all the sites, all the 5 study areas, the DEM data, the land use, the soil, and surface geology. Then the methodology used in processing the data. We use several GIS processing models, and at the same time, we're able to get out the flood risk indicators. You can see the methodological framework, the spatial data, the DEM, the land use, the soil data, and the geology. We use it to create the runoff model, and the inundation model from the DEM and the rain grid. At the end of the day, we're able to create a raster fusion model and the flood risk maps, which is our target, just to support not just predicting, but also to be able to map areas that are very at risk. These are some of the submodels based on what was earlier mentioned. We're able to develop the major ingredients which we use generated for the final model, which are as shown for Nigeria. the Ono River Basin, elevation, slopes, drainage, density, and others. We're able to subject them to hierarchical reclassification, rasterization, and resampling. So let's look at the results. The Magnitude Bay flood risk map. We're able to now use that to create the flood risk rank and the flood risk magnitude. The flood risk ranks rank from very low to very high, and based on the various are repetitive. The flood is with based on our initial inventory. And this model was generated using the hierarchical and weighted linear raster fusion techniques, which was achieved. We move on straight because of time. Flood risk areas, we're able to generate the flood risk area in kilometer and then by percentage and by size in hectares. For all these sites, we're also able to develop the flood risk the flood risk area susceptible mapping, the Ono River in Nigeria, the Bonomin Palmera in Abidjan, and White Volta in Burkina Faso. We did some field validation, which we were able to overlay the building footprints along the flood extent. And we're able to locate some of the buildings that are really on the floodplains. Part of what we carried out is the flood damage assessment, and we are able to actually categorize the settlement at risk, and both in Black Volta, and at the same time, this will allow for immediate alert for people living in those areas. This is just the flood. Let me see if it can work. Just simulation of the flood, which we carried out. For just with the input data, we're able to simulate, and there we're able to generate some of the extent of the flood. We can then move on. Let's see. The damage assessment was also a very important part of the work carried out. This is very useful for insurance and settlement, and then provision of support for the affected local people. Some of the trainings carried out, we had about 8 short-term trainings on disaster management, disaster management organization, telling them about flood simulation with aircraft and potential flood risk using the QGIS. Glovers could be used, as we noticed, to generate predicted precipitation data. However, we are informed that they are not fully validated, and hence we need more credible data sets for flood model, which currently is working fine with us. The model is required for flood damage. It's not just to predict, and also meaning that we only need predicted, accurately creditable predicted rainfall data. The products from this project goes beyond just predicting flood. We'll have the flood reporter. We have the geospatial database, which has been created, which in the phase 2 now we are bringing down and then improving on it. Flood forecasting, we did a lot of capacity training, flood damage assessment, the flood event database for the whole of the area has been created so that we all use the same instrument or the same format in the creation of the database.
Could you be concluding? Yeah, thank you.
I'm concluding now. Well, just to show one of the publications we had on the work. It is published in International Journal of disaster risk reduction. Now, the challenges is that there are inadequate historical data for products development, that the past flood events, and the precipitation data, there are a lot of gaps, and at the same time, predicted rainfall data are very difficult to come by. And no uniformity of data collection instrument, inadequate in-situ monitoring stations on our waterways for real-time data needed. Not all data layers were uniformly available due to differences in basin locations. Data gaps are not well documented. So the way forward, extensive in-situ data acquisition campaigns, we need to do that. Most of our mandated organizations are not keeping to this. Harmonization of instruments, development of monitoring stations, and continuous updating of national and regional hydrological data. Thank you very much. Let me stop there. We can I can answer more questions when necessary. We can cover what we have done for almost 4 years in 10 minutes. Thank you.
I agree. The time given to you was too short for such a nice presentation. Mapping these flood risk and the early warning you are sending to communities, the training, this is really fantastic. But we don't have much time, and we'll be able to answer questions that people are putting on the Q&A, and we'll have Q&A questions later on. Thank you so much. But before I move to the next presentation, I would like to put up a question, because we would like to know the participants' knowledge on the use of satellite data. So I will give you the question, and you'll be able to put in your responses. So the question is, have you already used satellite hydrological data? So you can give your answers, and after the second presentation, I'll give you the results. May I also remind you that this session has interpretation. You can click on the bottom where you see interpretation and choose the language you would prefer. Now I will call on the second presenter, who is Mohammed Hassan. Mohammed is a very experienced water resources scientist. He's now working as hydrometeorologist in ICPAC. He has over 20 years of experience in water resource management, and he will be presenting the floods and water resources forecasting in the Greater Horn of Africa. Mohammed, you have the floor.
Thank you very much, Marianne. Can you hear me?
Yeah, I can hear you and see your presentation.
Thank you very much. My name is Mohammed Abdullahi Hassan, a hydrometeorologist based at the IGAD Climate Prediction and Application Center in Nairobi, Kenya. So today's presentation is on floods and water resources forecasting in the Greater Horn of Africa. So the outline for my introduction, basically introducing to you the ICPAC and our activities, the need for remotely sensed data and information for our work, currently used data, as well as the use of the data and challenges and opportunities. So the IGAD Climate Prediction was actually initially established as a drought monitoring center in 1989. And then later on, it split between Southern Africa and East Africa. And in 2003, the IGAD Climate Prediction and Application Center was born. And IGAD has 8 members, and ICPAC serves both the IGAD 8 members as well as the 3 other members, Burundi, Rwanda, and Tanzania. So we are also the WMO Regional Climate Center as well as the NEPAD Water Center of Excellence. So the mission for ICPAC is basically to provide climate information and early warning support sustainable development in the region, to strengthen collaboration between the national hydrological and meteorological institutions on issues regarding observation and data management, as well as to develop a broad-based regional climate prediction and early warning systems. There are many services, but basically I would like to talk about the water resources here and also focus on Earth observation. So here in water resources, we actually carry out both capacity building, forecasting for seasonal timescale, as well as shorter timescale for flood and early warning. The region, we divide the region because of the computational capacity. We divide it into basins or groups of basins, and mainly there are 6 zones and one zone. The Nile zone 6 basically is just one basin, but the rest are a group of basins. So what is the need for remote sensing or remotely sensed or Earth observation data for flood and water resources forecasting? We have challenges here in that the hydromet network is very sparse. There are very few stations, and out of these also they have technical problems. Very few are reporting in real time, even to the National Hydromet Institutes. And also we are not able to get this data in real time. So we have to rely, because of the expanse of the area, we have to rely on remotely sensed data for our operational work. So currently we use a variety of remotely sensed data or Earth observation data, static data like land use and land cover, water level data basically from satellite altimetry for lakes as well as reservoirs and major rivers. And inundated area, this is basically done after the event, post-event mapping. And also for operational modeling, we use precipitation and PET from remote sensing. So here I just give examples of water level, lake surface area, as well as precipitation data. So here we use remotely sensed data to set up hydrological models, to calibrate and validate these models, to carry out operational forecasting, as well as to monitor the status of the water resources in the region. I just give you an example for calibration. So we use DEM for catchment delineation, and together with land use, land cover data, as well as soil data, we can extract hydrological as well as hydraulic parameters for one of the models that we use, which is the GeoSFM, Geospatial Stream Flow Forecast model. And most of it, because of lack of observed data, we use the observed remotely sensed data. And for calibration, so basically the major data we use here is water level, satellite altimetry data. And here I gave an example. So for lake components in the model, in the water resources model, we need to be sure that the model can predict the lake level or the reservoir level very well. So because of lack of observed data here, we use remotely sensed data to calibrate the model and get the best parameters for that. And this is very handy because of lack of observed data. For operational forecasting, I think this is the biggest challenge area because we don't have real-time data. So we use satellite-based precipitation. In this case, examples that we use for operational modeling, IMAGE and RFE. These are near real-time data. The latency is less than a day, so we can use it for operational modeling. We also have the global PET, which we also ingest in the model for initialization. And then we couple this with forecast data, GFS, and then run forecast short-term stream flow forecast. And for after the disaster, so in 2020, we faced a big challenge here because of heavy rainfall that led to a lot of flooding. So the lake levels expanded and people are displaced. So we were able to quickly try to use Sentinel as well as Landsat data to map both the increasing surface area of the lakes as well as the increasing levels, and we are able to produce such maps. So this is the post-event or post-disaster mapping. So this is my final slide. So going forward, we have a few challenges and also opportunities which we can take advantage. One of the challenges is basically that the satellite precipitation products have biases, and the stations used for bias correction in these regions are very few. So we still have that challenge for using bias precipitation, satellite precipitation that has bias for operational forecasting. On the other side, we lack also the capacity to operationally, get this data and feed into our models or to our system. Particularly, the satellite altimetry data. Still, we don't have that capacity very much, but we hope to access or to be able to use it operationally. So the satellite water level can also be used for, data ingestion into the model or data assimilation to adjust the model parameters, but you need to have, continuous data inflow into the system. On the other side, I think we have opportunities also going forward to collaborate with global data producing institutions who have relevant skills and capacity and benefit from that. And also, I believe there are new satellites coming up, and we should position ourselves to take full advantage of these upcoming remote sensing products. I think that's all. Thank you, Madam. Over to you.
Thank you so much, Mohamed, for this very informative presentation. We learned a lot, and it's good that you note that the satellite altimetry, you need some capacity, and we have a presentation on that. That's why we kept it at the end, so we will learn more from that. Thank you so much. Now,
thank you very much.
I will move to the next speaker. May I also remind you that you can still put your questions under the box on question and answers so that we look at them at the end of this session. So I will call on François Tayi-Takire from ARC. François is an expert in agro-resilience, food security and nutrition, and he's now the Director of Research and Development Department at ARC, the African Risk Capacity. François, you have the floor, and you have 10 minutes too.
Okay, yeah, thank you, and good afternoon to all the participants. And yeah, as the moderator said, I'm the Director of the Research and Development Department at the African Risk Capacity, which is a specialized agency of the African Union. But before joining the African Risk Capacity, also I worked for the Joint Research Center of the European Commission, and where I think I used extensively remote sensing data. And I would like to say a few words about African Risk Capacity. I don't have a slide, so because I think that most of the information that should have put on a slide have been already shared by different presenters, because basically we're using the same data. The African Risk Capacity, as I say, is a specialized agency of the African Union. The mandate is to support African Union member states to better manage disasters. One of the mechanisms that African Risk Capacity is proposing to its member states is the disaster risk financing through an insurance mechanism. This insurance mechanism aims at to provide to countries financial resources to respond to a disaster immediately after the event, instead of using the traditional or the humanitarian appeal approach, which usually takes a long time and delay the response. So the full proposition value of ARC is to make sure that the response is timely and also is predictable. Being an insurance mechanism, countries can actually know in advance which level of resources they will have access to when there is a disaster. Because when you sign the insurance contract, you know how much the maximum that you can get as a payout. and so that we can plan for that, and the country can decide to release some budget instead of putting in the reserve for future events, that they pay the insurance and then they can plan for the potential response when the payout happens. So the mechanism of ARC is based on parametric insurance, which means that when there is a disaster, there are no teams sent in the field to assess the damages. The damages are modeled upfront. So which means that the payout will be calculated based on the output, on the result of the model, estimating the damages from the event. So here you understand that in the case of flood risk, it's challenging to model the damages in terms of economic losses and also in terms of people affected. As other speakers were, I think, presented, they showed usually most of the applications that we have today are based on flood risk assessment beforehand. But when it comes to real-time monitoring or forecast of flood events, there are still many gaps in terms of technical development. One major gap is actually translating the stream flow forecast, basically what the role of the rivers, into actual inundation maps to have the actual extent of the flooded area. Once you have the extent of the flooded area, you need also to build I'll say vulnerability functions that will link the water depth to the damages. So you see that there are many challenges, and with the vulnerability functions also, then you have to have the exposure data so that you can estimate the actual impact. So here comes then the remote sensing part, so the Earth observation, which is providing many input data, as the others say, starting from land cover and land use derived maps that are derived from remote sensing, rainfall data. So rainfall data that we use for now is based on ECMWF forecast, but we are also considering to use near-time rainfall estimates from Hydrosat, for instance. Especially in the case of near-time observation from meteor satellites, will be useful for addressing the question of flash floods, because the traditional meteorological forecast, the CMWF data, are good for also forecasting the stream flows for the river floods. But when it comes to flash floods, it's challenging, and we believe that remote sensing can help to resolve the issue of the flash floods. The second use of Earth observation mechanism is the validation of the model. So basically the flood extent, we try to use high resolution satellite data like Sentinel, both 1 and 2, to map past events to verify if our model is correctly forecasting the past events. Then we use also the satellite imagery as post-event verification when the satellite data is available. Here also you understand the challenges that we have, because the flood will happen when there is a rainfall, and so that's also where we have the cloud coverage, which means that this limits also the use of optical data. So we have to resort to SAR data. And the challenge is here that for SAR data, high resolution SAR data easily available is only from Sentinel-1. And Sentinel-1 coverage on over the African continent is not that great because the continent is big, the satellite footprint is not that big, it's small. So usually we miss out many flood events. So that's a challenge. Going forward, we are now negotiating with other satellite data providers to have access to more sensors so that we can fill the gap. And I think that has also mentioned that data coming from Earth observation, like digital dimension model, etc. So I'm not going to repeat that. So in terms of, as I said, the challenges is to get now high resolution rainfall data that to feed high resolution flood model. Our flood, so the capacity to run flood modeling in real time. This is a big challenge because most of the flood modeling have been designed for flood risk assessment, not really for real-time monitoring. And the second challenge is the validation, including the exposure data. So where do people live, where buildings are? I think this is another area of improvement in the use of satellite imagery. I am happy to also to learn many of the applications from the different African institutions that are presenting here, and we are looking really for we're looking for collaborations so that we can leverage on the expertise of everyone. We are covering mainly the West Africa and Eastern and Southern Africa. I see that the organization working on West Africa and also ICPAC are key organizations that we would like to collaborate in terms of joining forces in terms of flood modeling, especially with this mindset of providing actual early warning in terms of potential impact of the coming events, and after the events also assessing the damages both on people affected, but also in the economic losses. Yeah, I would pause here. If there are questions, I'll be happy to address them. And I think it was a longer seminar. There's a lot of information, but you can visit our website, which is simply arc.int, like international. Thank you very much.
Thank you very much, Francois, for this very nice presentation on how ARC is using Earth observation for flood insurance. But it is very tricky because you have to work out the payout, so it's very tricky. And you mentioned a lot of challenges, but I think there are a lot of more opportunities that are coming out with MTG, with very high resolution, and the opportunity you can have also in collaborating with other institutions. But thank you very much. So we'll be posting the questions. Participants, do post your questions in the Q&A, and after we'll have a session to answer all those questions. So thank you very much, Francois. And I will now call on the other presenter, Jeremy Naidu. Is Jeremy available?
Yes, Chairperson, thank you.
Thank you so much for joining. So Jeremy will be presenting the use of Earth observation satellite for hydrological purpose in South Africa. He's now working at the Department of Water and Sanitation in South Africa and has a good experience in flood forecasting and early warning for dam operation and flood risk management. Jeremy, you have the floor.
Thank you, Chair. Good day to everybody, and thank you for the opportunity to share some experience from South Africa. Just a quick outline of what you will find in my presentation. Basically, I'm going to touch on two aspects. One, initially looking at the status and trends of in situ hydrological monitoring networks in South Africa, particularly because it does have some links to satellites and Earth observation requirements really from a national hydrological services in South Africa. I know a lot of the discussion so far today really focused on flood forecasting and the use of satellite products, which I think is quite important. But before we get into the details of satellite imagery, I think it's important also to understand a little bit about the history of hydrological observation networks, especially in the National Hydrological Services environment. What I have in front here on screen is basically a trend analysis of in situ monitoring. I know a lot of the countries here today mentioned that limitations in data and, you know, actual in situ data is very crucial for validating, you know, the results of the hydrological models, which are in a lot of cases using satellite precipitation as inputs. So if you just look at the trends for South Africa, there was quite a rapid growth in our in situ monitoring network up until the 1990s. And thereafter, it's sort of the number of stations really reached an equilibrium, really. So it's not really increasing that much. But all I can say for South Africa, we generally are quite data rich compared to other countries on the African continent, and you know, that helps us really when it comes to calibrating our hydrological models, whether it's for water resource analysis or whether it is for flood forecasting purposes. This is basically one of our sites located on the Great Fish River in the Eastern Cape province. It's quite crucial, and I would like to use this particular case as an example to show how I actually use satellite data to improve the high flow rating curve for this particular structure. So what you see in front is a crumb structure, which in South Africa, we really have a lot of these artificial controlled structures. And the reason for this is for high accuracy of basically low to medium flows. And these structures generally have a limitation in terms of the discharge that it can estimate. However, we have to then apply indirect methods to be able to calibrate it for much higher flows. And, you know, that's where the role of satellite data becomes important, where we can use data sets like digital terrain models or digital elevation models that can give us good ideas of the floodplains. And that's quite crucial when you're trying to estimate a high flow. So certainly satellite applications have played quite an important role. So basically for that particular structure, we set up a hydraulic model. If you look on the screen, if you go back into history, we never had the luxuries of satellite precipitation looking at extent. So what was done back in the day was flood marks were basically picked up by people and then surveyed. And, you know, that information was quite crucial when we then did the flood modeling to determine, you know, what is the discharge at the particular monitoring site. And then we could use that discharge value to have more confidence when we are extending the rating curve. So this was basically the results from that particular analysis. We're able to extend the rating curve. And, you know a lot of the applications are on flood modeling, and no doubt in South Africa, we are doing that. And you'll see from my slides that are coming. But it also shows that even in situ monitoring, satellite data can be quite crucial. However, one of the biggest challenges that we face, and I don't think it's just South Africa, I think is abroad, is really access to high resolution digital elevation models. It's definitely not open source at this stage. I think from some of the presentations that I heard earlier, I think 12.5 meters was what was being used. And this data doesn't really capture the channel cross-section area. So, you know, as a requirement for hydrological services, if we could get much higher resolution, you know, open source data for channels, it would greatly improve our ability to rate our structures or rate our monitoring sites for much higher flows. And so when we're doing the hydrological modeling, we can then get better results, especially in the high flow range. So this was a particular model that was set up, which we are currently setting up, HMS for the Vaal River system. Also quite a complex system with basically two dams, one being the upper dam, which we sort of use for flood attenuation. It's gated. But I mean, without satellite products and inputs, we would spend hours delineating catchments, determining river lengths and so forth. So from a hydrological services point of view, the value in the satellite products it's ranging from digital terrain data to satellite precipitation data to various other products like we've seen earlier, soil moisture and so forth, that help us to better understand, you know, the hydrological processes in the catchments. This is another example from South Africa where It's actually transboundary river basin. It's the Limpopo River Basin cutting across Botswana, contributions from Zimbabwe, South Africa, and actually the impact mainly felt in Mozambique, which is the outlet. The upper countries is where the runoff is really generated. In this particular model, I think 3 gauging stations more or less were used to calibrate the model. In this case, like I mentioned, if there's no high resolution digital elevation data, then we have no choice but to look at a higher cost where you have to get actually drone survey done to bring in LiDAR data. So if we get more access to satellite data products, especially on the actual channel itself, that will greatly improve the modeling that we're doing. And so that if a flood forecasting system is developed, we're not giving bogus results and evacuating communities without having high confidence in the results. So yeah, I think it's going to take a both combination of satellite and in situ monitoring to develop a good solution in the space of flood forecasting. And yeah, we definitely need the satellite products. Sitting in the National Hydrological Services, you're not necessarily just a remote sensing specialist per se, but a lot of the focus in this environment is on the data collection at gauging stations. But I think there needs to be careful thought in terms of how we capacitate hydrological services to make use of the products that are coming out at lightning speed. Other stuff, maybe not so technically developed, is just just satellite imagery. Having good satellite imagery helps you to better interpret some of the plans. In a lot of the modeling, we may include a dam with gated spillways. Sometimes just looking at the plan doesn't give you a good idea of what the actual site looks like. So satellite imagery definitely just for screening and determining access routes, putting in plan data into models is quite useful. And I think, satellite providers are really showing us the high resolution that's coming out today compared to decades back. And yeah, it's just getting better and better. I guess as hydrological services, we sort of need to keep up. One more application that I'd like to touch on, I know time is limited, is network design. And I think for many countries, they're still developing their monitoring networks. This is basically a picture of the design monitoring network for South Africa. The network is redesigned, still very much in implementation. But without satellite data products, we would never been able to identify, where's the opportune site to monitor, which sites have accessibility, and things like that. So satellite products definitely influence the way in which we determine the design and our approaches towards network design. I think a lot of this has been covered, but I think from a National Hydrological Services, satellite imagery, more high-resolution digital elevation models, as well as constantly getting better precipitation inputs at higher resolutions, better soil moisture products so we can model better. There's definitely, things that National Hydrological Services need, to be capacitated. Thank you, Chairperson.
Thank you so much, Jeremy, for giving us the experience in South Africa. Very nice presentation showing the added value of combined use of satellite and in situ data and the issues, challenges we're having in flood forecasting, the need to access high resolution data, digital elevation. Thank you so much. So will participants do post your questions in the Q&A. We'll come to that in a minute. And I don't know whether the results of the poll is available before we go on to the question and answers. Oh, very good. Here, most of you, 60% have a good knowledge of have a good knowledge and have already used satellite data. 61%, 51% of 49% who don't use, who have never used satellite hydrological data. So you have a very good knowledge of that. Good. So congratulations. We can move on to the question and answers. I see that most questions have been already answered. Most of them are answered. Just a couple of them are remaining. Let me see. But there were, yes, a good number of you were asking why do we use these satellite data instead of using real-time precipitation. So I have a question here from Sarah asking why don't you use real-time precipitation and which kind of model are you using? Semi or fully distributed, and to give the name. But we didn't ask to whom these questions were, but probably it's for Ganiyu and Mohammed, because they were the first presenters while you were asking the question. So Mohammed or Ganiyu, if you would like to answer this question.
Yeah, I can try if that is okay.
Yeah, please go ahead.
Yeah, so currently we are using lumped models and not distributed models, and we're just doing research on distributed models, but operationally we are using lumped models for subcatchments. There are close to 4,000 plus subcatchments in the region. The second question was, okay, we can't use real-time precipitation in observed precipitation, so we don't have the stations that are reporting. That's why we're using satellite estimated precipitation, both in the hindcast as well as in the forecast. Thank you.
Thank you very much.
Well, I don't know if we can add one or two. It's very similar to what Mohammed have really given. When you are talking about real-time precipitation data, one, it is most of the stations you don't have them. We're planning to have what we call sensors, or they're using the Internet of Things. And in most cases, that is used for nowcast, not for forecasts of flood. So it's, we need forecasted precipitation data to make prediction, to make forecasts. So that is what is actually needed. And which one can I answer again there? Well, we use the aircraft, but the model is actually an hybrid one. It's a combination of from aircraft model to GIS or whatever. But I agree with what the answer given by Mohammed so far. We just added data precipitation data to make sure that real-time data is costly, yeah, but it's mainly for nowcast. Thank you.
Thank you. And may not be available as well. The network is quite scarce, and you need these remote sensing data, satellite data to cover up, I guess. So another question still for Mohammed. Which locations are you measuring water level with altimetry data for calibration? Is it being done only in lakes or also in rivers? What challenges have you found in setting up this altimetry system? It's for Mohammed. This question was from Amin Shakia.
Thank you. Okay, so for calibration, we did process data for most of the water bodies, lakes and reservoirs that are in the model that are being modeled, and also large rivers that we can get because the GSFM model can give also water levels. So that is historical data we did download and use it for calibration, but for monitoring, it's not operational as such, and we have to figure out how to do it operationally. Thank you.
Thank you, Mohammed. Another question from Fred Cariou. He would like to know how research institutions and students in Africa can access the data from the European satellite, and if there is, what is the procedure for accessing it? It's both for
that is straightforward.
All of you, eh? Yeah.
That is straightforward. Just go to the Copernicus website. EUMETSAT can help with this, and you can just register and state what you want to use the data for. You have the access to it. It's so straightforward. I think Vincent can also come in on this. Thank you.
Yeah, Vincent, please.
Yes, good afternoon, everybody. Hope you can hear me. Yes, on this one, actually, we will have the next sessions with the 4 presentation also will also provide more information on where to access the data and where also to find knowledge on how to use the data or how to access training materials from the various data sets that are provided from EU or EUMETSAT satellites. So this question will be better answered in the next 4 presentation, actually.
Thank you, Vincent, for that. And there is a big demand of participants wanted another webinar like this one. It's very interesting. So I think EUMETSAT will be able to plan it sometime later on. People are finding it very interesting. And I still have 5 minutes. I have a very long question. I better go for the one for AK. AK, you have a question from Henriette at Teba. If satellite footprint is not enough and coverage insufficient for Africa when using Sentinel-1, is the precision level of data allowed to have good prediction? Okay. This is for AK. François.
Yeah, okay, thank you for the question. I think the main challenge in using Sentinel-1 in our operation is the low temporal resolution. So the revisit time is too long. So, but when we are lucky to have acquisition at the right moment, the spatial resolution is good, and the details that we can get also for bad footprint mapping is sufficient, is good. But I have to clarify here, we're not talking in terms of prediction, it's about assessing the flood extent after the event. I hope that I addressed the question. Yeah. Thank you.
Thank you, François. A couple of more minutes for the questions from Nimdu Abukele. So I'll just get the last questions on, it could be for all of you. Could you elaborate on the process of calibration your hybrid model and how are you sure of their accuracy? How does your hybrid approach handle aspect of prospective flood risk modeling? What are the sources of uncertainty you considered? And how does your methodology anticipate future changes such as climate variation and land development? I encourage you, all of you, to answer this question on the Q&A. And if any one of you would like to give some response. Jeremy,
well, can I there are some of the questions I can answer, but these are too long questions to be answered within this kind of short period. That's why the presentation is there, and that's why we need to continuously contact each other. That's in general. Right, with regards to the question, how do you select the study areas to apply your hybrid modeling approach? Well, this is a collaboration of institutions across various institutions in 5 countries as regards the MIFMAS, and it's left to the partners to really, since we are dealing with riverine study areas, it's left for them to pick the river basins that they believe has a lot of issues with regard to flooding within the area. So it's what they provide and their location that we're able to then map and download from the various, especially the Copernicus website, and which we use. So we have no condition restricting them to say, no, pick this, don't pick this. So there are institutions of repute which we believe we are collaborating with. That's, I can tell you. But with regards to how do you manage technical challenges associated with integrating these 2 types of models? We're able to, in the presentation, if you look at the presentation or you have the link, you can then get back to us. We try to explain to you what some of the things I mentioned in the presentation. We are just stop there, but we can still continue to discuss it. I can also tell you that on GMS and Africa Phase 2, we are improving on the model. We are also working hard. We've had 2 papers presentation, 2 publications. I was able to show you one during the presentation. So we have published work on it. So, but we continue to dialogue, we continue to talk about it to improve each other's understanding of what we have on hand. Thank you very much.
Thank you so much, Ganu. You can still answer those questions on the Q&A box. And thank you all for this nice presentation and all the questions and answers. So we'll move now to the last part of this webinar. It's about accessing the Earth observation, hydrological data, and knowledge. And the first speaker is Luca Broca. We'll be speaking about the hydrology stuff, the soil moisture products, the description, access of the data, and how to use them. And Luca is working now as a director of research at the National Research Council, the Research Institute for Geohydrological Protection in Perugia. Luca, you have the floor.
Thank you very much. Can you hear me? Yes.
Yes, we can hear you and can see your presentation.
Very good. And good afternoon to everybody. My presentation will be the first one, presenting the products developed under the HSAF project by EUMETSAT. And HSAF is the Satellite Application Facility for Hydrology. And this first presentation will we will talk about the soil master products that have been provided in the project. Of course, I will talk about on behalf of the HSAF soil master team, and particularly the people from ECNWF and from Technical University of Vienna. Second slide. Yeah, let's start from here. There was a paper just published a couple of days ago, in which basically the problem of Africa, in which basically the toll for undue exposure to climate catastrophic events is much larger than even Europe and North America together. And one of the main issues is related to the deficit of weather station, as also was underlined by previous speaker also this morning. And yes, there is the strong need of improving ground observation of meteorological data like precipitation, so moisture evaporation. But of course, satellite data can be very helpful in this respect. I will talk to you about the soil master products developed under HSAF projects, and there are basically two products. One is all this product is available in near real time. Is surface soil master, so it is soil master for the very first 2 to 10 centimeters of soils. The data are available from 2007 to now. The data has a spatial resolution currently, spatial sampling of 12.5 kilometers, but will increase to 6.25 by the end of 2023, also in preparation for the next SCAR mission that will be available soon. And data are available basically at the sub-daily scale. This map shows you just an example of a few days ago, at the time when I prepared the presentation, and this is the data that you can see from brown to blue. Of course, brown is dry condition and blue is very wet condition. The second product developed under HSAF is called Root Zone Soil Master, near real-time product. Also, this product is available in near real time at the 10 kilometer sampling, and it has 12-hour latency. The product is based on the assimilation of the surface soil master product into ECNWF model. And in the slide, you can see some details, but the most important thing is that the product is available for 4 different layers. from the 0 to 7 centimeters, 7 to 28, up to nearly 300 centimeters of soils. This is the product available in near real time, and there is an analogous product available as data record. The same is for the surface soil moisture. We have data records, so a long-term product for the surface soil moisture from 2007 to now. For this root zone soil moisture, we have data from 1992 to now, so we are able actually to really look at what is happening today with respect to the very past. So, how to download the data? We have a website that you can find, that you can see on the slides on the top left. You will get a username and a password, and so you will have the access to the FTP website. And from that, you will be able to select near real-time data sets and also the data records. In the HSAF website, there is also all the documentation related to the product, like the ATBD, the theoretical baseline for the algorithms, the product user manual, the validation report in HSAF, but also in all the SAF projects. There was a lot of validation of the product, so you can see the validation done also everywhere in the world. And also we have material for training. So for instance, we have material at the last event week that we made in early this year, I guess. And we have also training material on GitHub for actually the actual exploitation of the data. Of course, today we don't have data, we don't have time for showing you all these materials, but everything is available online. And in the near future, there will be also an online platform that will help everybody to access the data, to work with the data, to understand what can be done with the data. Then, a question for the audience, because I talked about soil moisture, and so the question for you is, why is soil moisture important in hydrology? To answer the question, you can scan with your mobile the QR code, or you can go to slido.com and insert the code SM for hydro in the lower capital. And you can start replying to this poll, telling us why is soil moisture important in hydrology, selecting one of the potential replies. I don't know if people is starting to, people is starting to connect, and it's starting also to reply. I will keep the question open, so you can continue to answer also after, because actually today I have little time to stay on a question for, I will stay here for another 30 seconds, let's see. But you can continue to answer. And for instance, for the people answering so far, but there are quite a few with respect to the number of participants. Yeah, you can see here now that also you can, in real time, you can see the different answers. But the real answer to this question is that there is no single answer. Actually, soil moisture is important for all the topic that are shown here. So it's not only drought and floods, it's water resource management, it's soil and slides, crop yield, and also fire monitoring and detection. I will show here some example for African countries, but actually we have much more that can be presented. Let's start from, for instance, drought monitoring in Mozambique. This is a project led by the University of Vienna, and they are working on developing drought indicator for the Mozambique. On this top left, you can see the map of drought developed with the HSAF soil moisture product, categorized from no drought to extreme droughts. There is in the central part, you can see the map from the standardized precipitation and evaporation index. That is the classical way of monitoring drought. And you can see that there is good agreement in Mozambique in detecting the areas in which drought is more important, but the spatial resolution of HSAF product is much higher. And also you can see on the bottom left, on the bottom right, a time series, and so you can track the status of soil moisture for each point or for each location, for each region, quite easily by using HSAF soil moisture products. What is important, actually, we are doing the presentation divided by product. So I'm going to talk about soil moisture only, but actually one of the main, the most important things that we should think about is that the integration of multiple products, precipitation, surface, soil moisture, root zone, soil moisture, and vegetation, will provide additional information because, for instance, there is a time lag between when we have a deficit in precipitation, it will be reflected in surface soil moisture after, for instance, 1 month, root zone soil moisture 2 months, and vegetation later. So if you have this in the plot, you can see maps for every 10 days from precipitation, surface soil moisture, root zones, and moisture, and vegetation. And you can see that, for instance, this is the drought occurred in Senegal in 2014. And you can easily see that first, you can see it in precipitation, then you can see in surface and root zones, and moisture, and finally in vegetation. So basically, we can, by using multiple products, we can monitor on drought in time. And we can also predict what is going to happen in the future by using, for instance, precipitation and surface soil moisture. This is another example, very, very recent. My colleague from ECNWF made the map for the 17th of August in 2023. And the left is a map of anomalies of root zones and moisture. And on the center, you can see a drought hazard index computed as standard deviation differences between the long-term average. And for instance, from this product, we can see that particularly Central Africa is currently experiencing a very important drought condition with severe condition spread out over the whole Africa. And similar also is happening in the northwestern part of Africa. And the data are available at 10 kilometer resolution, so you can also track quite nicely the spatial occurrence of drought. We have talked about drought, but for instance, this is the results. These are the results for one study. On the left, on the right part of the slides, you can see some references, because of course today I can give you much more details. But either you can contact us, either you can see the slides and you can have an access to the papers. But what we found here is in this paper, we perform an evaluation of different soil moisture products, not only from HSAF, but also from, for instance, SMOS and SMAP from European Space Agency. And we compared the capability of each of them to estimate antecedent wetness conditions that are very important before a rainfall event to understand if precipitation will provide a flood event or not. We found very interesting results for multiple catchment in Morocco, and actually we have done also similar analysis in other parts of Africa. Agriculture, yield prediction. So for instance, this is another study that we did in Morocco, and again, this is funded by World Bank, and basically we wanted to predict crop yield. This is the case for barley. On the right, you can see the animation of yield prediction that we obtained by integrating not only at the beginning, for instance, if we use only precipitation and vegetation index, we get these results, but adding soil moisture, basically we are able to improve our prediction, particularly over dry condition, and this is what we expect. Final application is again, by integrating multiple satellite products. This is a study that we have done a few years ago in the Upper Blue Nile. And by integrating satellite soil moisture, but also precipitation and evaporation data from satellites, we were able to close the water budget for the basin. And so we are able to estimate, for instance, the different components of the water cycle for the long term. And this is very important, for instance, for water resource management. So, conclusions. Satellite soil moisture products are available in real time, also for the long term. As I mentioned you, they are available for more than 20 years already. And their exploitation in hydrology and agricultural application in Africa will certainly represent an advantage in knowledge, and also will be extremely relevant for real-world application. And the problem also mentioned by some of the speakers before than me, basically data are available, data are there, and not only for SOLMOS, but also for the other products, as will be shown also by my colleagues in the next presentation. And probably one of the more important issue is not actually the data availability, but the capacity building, that basically to make the data available to the user and also to train the user not only to understand where the data are, but how to use the data, how to use the data for their application. So basically, all this stuff is very important, not only in Africa, but everywhere, if we want that satellite data will be exploited in the future. Thank you very much for your attention. You can see in the slide some contacts. Any question, I'm happy to answer in the next half an hour.
Thank you very much, Luca, for this very informative presentation, showing the data satellite on soil moisture from the hydrology SAF, where we can find them. You showed the ASCAT soil moisture, the root soil moisture, and the website to download them, and also find some training materials, but you need to register. And we've seen also a very nice example on the use of this soil moisture in drought monitoring, flood forecasting, water budget, and so on. So you have the website to register. So do register and get the data. Thank you so much. Questions, please post them on the Q&A and we'll answer them as we go. And also there will be an open Q&A where presenters can answer you directly. But before I call on to the Luca, I would like to post some questions that we had to answer before we move on. Let me see so that we can open the poll for the second question. What would you need to use Earth observation hydrological data efficiently? So you can put your answers and we'll look at the answers before the end of the session. What would you need to use Earth observation hydrological data? Put in your questions and I will call on the next presenter, another Luca Chabata, sorry, who will present us the precipitation product from the hydrology SAF. And Luca is another expert working for the Research Institute for Geohydrological Protection in Italy. And he has a very good experience in satellite rainfall and soil moisture data.
Yes, thank you, and good afternoon to everybody. I hope you can hear my voice and you can see my presentation.
Yes, you can hear you and see your slides.
Thank you very much, and thank you for the kind introduction. And I will give this presentation on behalf of the HSAF Precipitation Development team. And during this presentation, I will give you a brief introduction on the use of satellite rainfall data for hydrological applications. As already was mentioned by Sylvia this morning, the main goal of HSAF is to provide satellite products and support to operational hydrology. In this framework, the satellite observation obtained through low Earth orbit or geostationary satellite platforms can be used to estimate rainfall. We can distinguish two different kinds of product. The first one here on the left, I'm sorry, I will put the pointer, okay, here on the left, is based only on microwave satellite observation that can provide very accurate rainfall estimates at the satellite overpasses. Here you can see an example of this product. Its name is H67. It is characterized by a daily temporal resolution and provide rainfall with over a fixed grid of 0.25 degrees of spatial resolution. On the right side of the slide, you can see another product that is based on the on blending the information obtained through the microwave observation with infrared data. In this way, we can obtain a product that is characterized by a very high spatial and temporal resolution. We are talking about 50 minutes over a grid of around 3 or 4 kilometers. And it is available also for, in near real time. Both of these products are obtained by looking at by sensing the clouds from the top. While we can also use another technique that is on the other side, looking at the water that is already stored into the soil. So we can invert the soil water balance equation in order to estimate rainfall starting from soil moisture observation. In this way, we can integrate the soil moisture derived rainfall and the microwave derived rainfall in order to obtain a more accurate product. This particular product is named H64, and it is available starting in 2019, and it is provided operational within HSAF. All the material about the retrieval algorithms as well as the validation, as Luca already mentioned, is available on the website. All the data are available for free. You have to register on the HSAF website, in where you can access to obtain the last 60 days of data. Or if you want a longer time series, you can place an order, and the management will provide you the data in as soon as possible. All the data, the majority of the data are provided in NetCDF format, so they are very easy to be read. But we are also providing tools for downloading and reading the data in case you should face any problem. And moreover, we can provide support not only in reading and downloading the data, but also in using the data, as we are going to show in the next slide. As Luca already mentioned, in the website, there is also a section dedicated to the training material, in which you can find presentation and videos related to the project status and the product provided within the project, that are available both in English and in French. Switching to the application, I will show you how we can use this data in hydrology. As you may remember, in October last year, Nigeria was hit by a severe storm that caused more than 600 casualties and several damage to properties. We can use satellite rainfall observation in order to define where and how much it rained during this event. In this slide, you can see the anomaly map in terms of rainfall obtained by the integrated product that used also the soil moisture information, and the product that merged the microwave and infrared information. And we can see that in the northern sector, in the sector, north, the flooded area, we can observe a very positive rainfall anomaly that likely triggered this flood event. This is related to the period August-October 2022, with respect to the previous year. So here we can see really how one of the key factors of using the satellite rainfall data, that is the capability of providing the rainfall information with continuity in space without taking into account the border of countries. Here you can see the black dashed line represent the Niger River basin catchment, and here we can see that basically in the upstream of the upstream section of this of the river, we can observe a huge amount of rainfall falling in October that likely created this dramatic flood event. But we can also use satellite rainfall data to simulate discharge. And I present you some results that we obtained in a study carried out in Northern Africa. Here you can see on the right, you can see the results of the rainfall runoff model in terms of efficiency compared to observed discharge when the model is forced with several satellite rainfall products. Most of them are provided within the HSAF project. And here we can see how the satellite rainfall product, especially the one that is derived from soil moisture observation, can really provide quite good performance for almost all the catchments. Here you can see simulation of discharge for a basin in Morocco. And if we compare the observed discharge that is represented by the blue decline with the outcome of four different hydrological models, we can observe that satellite data can really reconstruct the discharge peaks very well. We extended this analysis for several catchments in Africa by using different satellite rainfall products. And here on the top left, you can see the overall performance recorded over the entire Africa. And we can see that one of the integrated products that is represented by this first box provided performance that are very close to those obtained by two very commonly used products in Africa that are ERA5, that is our analysis product, and GPCC, that is a product based on rain gauges observations. But if we look more in detail throughout the different sectors of the continent, we can observe that sometimes also the satellite product outperform this state-of-the-art data set. Like, for instance, what is going on Western Africa, for instance, or also in Eastern Africa. This is due to the fact that different physiographic and climate features can impact the retrieval of the satellite product, as well as the outcome of the model. This is one of the most important information that we can retrieve from these results is the fact that we can assess the quality of our product before using for an operational application, for instance. And here you can see some time series obtained from the previous studies. Here on the top, in the upper part of this the panel, you can see the time series obtained by forcing a model, with GPCC and ERA5 for a basin in the southwestern part of Africa, while on the lower part you can see the same time series obtaining by forcing the model with satellite data. The green line represents the observed discharge, while the red line, the simulated discharge. And here we can see that the satellite rainfall product can provide good performance, even though we can observe some underestimation of the peak discharge for some rainfall events, while, for instance, ERA5 performs very, very well. Here you can see the same graph, but for a catchment in Western Africa. And here we can see that the satellite product outperforms in terms of efficiency of the model the other two state-of-the-art product. In this particular case, we can see that the product that is based on observations performed the worst with respect to the other product. While, for instance, the soil moisture derived rainfall performed the best. And the last application I would like to show you is that we are able also to monitor extreme event that can occur throughout Africa. Here, for instance, we track this cyclone Idai that hit the southern eastern part of coast of Africa in 2019. On the right image, you can see the daily rainfall that is fallen during this storm, while on the right image, you can see the cumulative rainfall that's fallen during the entire period. And this is of paramount importance because we can track the storm. We can also define where and how much it rained. That is, I think, it's of paramount importance for civil protection purposes. So in conclusion, we have seen that the HSAF products are valuable tools for the monitoring of extreme events, and they can be used with benefit also for discharge simulation, providing sometimes better performance than those obtained by ground or model data. And one of the key factors of the satellite rainfall data is the availability in near real time that can play a key role in setting up operational early warning system in data scarce regions. So thank you for your attention. Here I have list some email addresses related to the precipitation HSAF team. If you want to reach us, just drop off us an email. Thank you very much.
Thank you very much, Luca, for showing these precipitation products and where to download them, the same website as the other Luca had shown. Yeah, you need to register and get all those precipitation products. You also showed the some example of use in discharge simulation. Very nice pictures, reminding me my early years of river flow modeling. And also the opportunities we can have to track these extreme events like you did for Cyclone Ida and usage for early warning systems. Thank you so much for that. Participants do not use those email address if you want to contact them. Everything you can find in the presentation that will be shared later on. For your questions, please post them on the Q&A. And we'll answer them as we go, and we'll have the opportunity to answer live at the end of the session. Before calling on the next presenter, I would like to have the poll results. If you could display them, please. Thank you, Luca, boss Luca. So here we are. The question was, what would you need to use Earth observation hydrological data? And most people answered that it's for training, about 50%. And the next one is on information on how to use the data, followed by information on where to find the data is an answer for what you need to use this data. And followed by improved technical capacities. Thank you for participating. But we need this data more than just training, yeah? Improve technical capacities and also some other examples that you've seen in these two presentations, and more to come with the products we can have for evapotranspiration. So I will call now on Miguel Barrios to present us the evapotranspiration products.
Yes, hello, I hope you hear me and you can see my screen.
Yeah, you can. So for you participant, Miguel is a researcher at the Royal Meteorological Institute in Belgium. Yes. He has a very good experience with Landsaf products. So he will now present us the evapotranspiration products from Landsaf. Over to you, Miguel. You have the floor. Thank you.
Okay, thank you very much. I am Miguel. I am presenting the evapotranspiration product we developed in the Landsaf program, and I present this on behalf of my colleagues. I know I have very little time, so I will try to make an efficient use of my time. I have three different parts of my presentation. First, a very quick word on what is the LSA SAF program, or as we call it, LandSAF, for those who don't know the program. Then the evapotranspiration product itself, and then I will wrap up with what I think needs to be remembered after this presentation. Well, the LandSAF program is a program by EUMETSAT. LSA SAF stands for Satellite Application Facility on Land Surface Analysis. So you can already guess that the focus of the program is to develop and process satellite products aimed to characterize continental surfaces. So no ocean here, but it's continental surface products concerning radiation, vegetation, evapotranspiration as the one I will present today, fires, etc. This is the menu of the products that are currently available in the LandSAF program, so you can take a look. I will later in the presentation give the address, but I will talk about only the evapotranspiration product today. The evapotranspiration product relies on the METEOSAT second generation. There are other products in the LandSAF that uses METOP, but evapotranspiration we calculate only with METEOSAT second generation. So a geostationary satellite. Okay, the evapotranspiration. What we understand here under evapotranspiration is the flux of water going from the Earth's surface into the atmosphere from water transpired from plants, that is transpiration, and also water evaporated from water bodies, reservoirs, the upper layers of the soil. This flux together is what we call evapotranspiration. And important to mention is that some authors say that this is perhaps the second largest flux in the water cycle. So even if we don't see this flux, but we are talking here a very important part of the water cycle. It's also a very important part of the energy balance. And this is what allows us to use remote sensing to calculate, because we all the algorithms, or many of them, they are aimed to calculate the latent heat flux, which is the energy flux that is equivalent to evapotranspiration in hydrology. So in our algorithm, what we calculate is latent heat flux. This is a scheme showing the algorithm. I will, of course, not go into the details of it, but perhaps very briefly, I divided this in four main steps or four main phases. Box number one is showing that for every pixel, for every cell in the METEOSAT grid, we identify up to 4 different land cover types, the most important ones. And then we move to box number 2. In each of these tiles or land cover types, the energy balance is computed. This delivers an estimate of latent heat flux for each of these sub-pixel units. And once we have done that, then we move to the box number 3, which is the integration into a pixel value. And then we do this 48 times in a day. That means every half an hour. At the end of the day, all the estimates of the day are aggregated into a daily evapotranspiration estimate. This is in a very, very short, the way it is computed. The inputs that we need is other LandSAF products, those concerning radiation. Of course, we need energy for evapotranspiration to happen, albedo, also information on the vegetation. This is also coming from other LandSAF. We use the HSAF soil moisture product that we have just heard a presentation in this session. Meteorological variables are coming from the ECMWF model, and EcoClimate database is what we use for identifying the different land cover types. It goes through the algorithm, and what it delivers is half-hourly estimates of evapotranspiration. As I have explained before, they are aggregated into daily evapotranspiration, which is perhaps what most users are interested in. And there is also half-hourly estimates of the surface fluxes. And this is more or less what the product looks like. At the left-hand side, you see a display showing a map, the whole area. This is daily evapotranspiration average per month. just for you to have an idea what it looks like. And the plots at the right-hand side are the one in the middle is the diurnal cycle. That this is a very special thing of this product coming from a geostationary satellite, allows us to characterize what the evolution of evapotranspiration is during the day. And of course, we can also aggregate to longer time windows like annual patterns and so on. How do we make the quality control, the validation? Our main source of validation is the eddy covariance stations scattered a bit everywhere across the world. Of course, we can see in the maps at the right-hand side that the density of this these measurement points is not really equally distributed all over the world. There are places or regions of the world with higher density, but of course, well, we have to work with what we have. We also look at other products that are similar, and these plots are giving a summary of what the statistics are giving at this moment concerning the comparison with eddy covariance station. We have in the horizontal axis the R square, and in the vertical axis the bias. So the region at the right-hand side in the middle is where we want to be, and this is locally where we see most of our points. So this is already giving a good sign of good quality. We also compare with other products, like what I'm showing here is like as an exercise of extracting data from boxes all over the field of view of the EUMETSAT satellite, and checking what the other products are giving for those for those regions, and see how our product compares with those. And we see that the very important cycles are captured, are very well captured there. All the products coincide in capturing these cycles. We are also interested in checking what the product looks like in the extent of watersheds. We have heard many presentations today about watersheds, so this is a very important geographical unit. Of course, we don't have here reference data to compare with, but it's always useful and informative to compare with other products, especially if they are delivering data that are coming from completely different methods, like as we see here. What other researchers do with our product is also very interesting, as in this publication is showing a study in South Africa where field measurements of evapotranspiration are compared with our products. They are reporting a very good coincidence. This is another study across the Congo Basin, where the authors were kind enough to share their data. In this study, they compare different products across the Congo Basin and also the output of hydrological modeling. So it was easy just to put our data next to the other data sets and see how is the comparison. And here also nice comparisons and nice coincidences we found. Many of our users are interested in the product because they'd like to test, or they would like to test drought indicators based on evapotranspiration. For instance, in this exercise in the Horn of Africa, when reference evapotranspiration, which is by the way another Landsat product, is compared with the actual evapotranspiration as a way of tracking the drought or detecting droughts in a particular area. How to access the data? So it's very easy and very similar to the other products. The only thing you need to do is to go to this address, to the Landsat server, register if you have not done it yet, and then it's really very intuitive to navigate throughout the folders and find the product you are interested in and just download. And I am arriving to my take-home messages. So first of all, for those who didn't know what the LSI-SAF program was or is, now you know it. It's a EUMETSAT program where satellite-based information is exploited to describe, to to generate products that describe the land and the land atmosphere interactions. It includes an operational product on evapotranspiration which is delivering estimates in near real time and at a high temporal resolution, so every half an hour. The validation exercises so far have shown a good quality. Of course, that doesn't mean we have not detected points that we have to improve, as is the case for all the products, I guess. Again, the data are freely available. There you see the address I have shown in the previous slide, but also the first one you see is let's say like the general Landsat address, where you can find also all the documentations, the validation reports, the description of the algorithms, and so on. And very important, we are currently working to get prepared for the MTG era. So all these products are coming on the MTG resolution. And then finally, an invitation to stay in contact. And please, we are very happy if we can receive from you questions, suggestions, reporting on your experience using the data, etc. Yeah, that's it. Thank you very much.
Thank you so much, Miguel, showing us all these evapotranspiration products, the algorithms to derive them, solving these differential equations. Life has become so much easier now. In my old time, you have to compute everything by yourself. Now data are available. Just click on the website, register, download them, and you even have the training material. Thank you so much. So participants do log on the website, any question, link up with the presenters. They have their email on the presentation that will be available. But before I call on the last presenter, I would like to open the poll again to put up a question to see which hydrological products do you mostly need? So the poll is open. Which hydrological products do you mostly need? And before the end of this session, I will give you the result of the poll. And the last presenter, and not the least, we kept it at the end because people are eager to know about altimetry so that we can keep them till the end. So Jean-François Créteau will tell us about radar altimetry contribution to river basin management. Jean-François is a scientist working with the Laboratoire d'études en géophysique et océanographie spatiale in Toulouse. And he's also a scientist for SWAT. So Jean-François, you have the floor.
Okay.
And interpretation is available. You can choose it at the bottom in case Jean-François speaks French, coming from the nice town of Toulouse, la Ville Rose. Welcome.
Merci beaucoup. Et je vais parler en français puisqu'on m'a autorisé à le faire. Donc, Jean-François Créteau, je suis au Lagos et je travaille aussi au CNES, qui est le Centre national d'études spatiales en France. Je vais vous parler donc d'altimétrie un petit peu sur les rivières, un peu les lacs aussi, et surtout de la mission SWOT qui vient d'être lancée. Donc, planche suivante. Donc, juste un petit rappel quand on étudie notamment le cycle de l'eau, comme on l'a vu à travers les différentes présentations jusqu'à la mienne, on est capable d'utiliser un certain nombre de missions satellites de télédétection pour les différentes composantes du cycle de l'eau. Donc là, j'en ai listé quelques-unes, mais parmi ces composantes du cycle de l'eau, on a les eaux de surface contenues dans les lacs et sur les rivières. Et pour ça, on utilise jusqu'à présent l'altimétrie satellitaire, qu'on assimile ou qu'on associe avec des modèles. Donc, moi, c'est ça dont je vais vous parler en quelques minutes. Planche suivante. Donc, l'altimétrie satellitaire, un petit rappel, je ne sais pas si tout le monde est parfaitement familier avec l'altimétrie radar. On a un instrument qui est embarqué sur un satellite, qui est un radar altimètre, qui émet une onde en direction de la Terre, au nadir, mais c'est simplement au nadir. Cette onde, elle est réfléchie, on applique un certain nombre de corrections, de propagation du signal dans l'atmosphère, et on en déduit la distance entre le satellite et la surface réfléchissante. Et si on connaît très précisément la position du satellite, à ce moment-là, on peut déterminer la hauteur d'eau de l'objet qu'on a visé. Donc cet objet peut être un lac ou peut être une rivière. On fait cela de façon répétitive, c'est-à-dire que ces satellites altimétriques sont placés sur des orbites donc dites répétitives, donc qui reviennent selon un cycle qui est variable en fonction de l'orbite, tous les 10 jours, 21 jours, 27 jours, 35 jours, etc. Et ça nous permet de construire des séries temporelles de variation de niveau d'eau. Donc là, j'ai juste mis 2 exemples, bon, on en a des milliers d'autres, sur le réservoir Nasser dans le bassin du Nil, et sur la rivière, donc là c'est sur un réservoir, on peut le faire sur des lacs, et sur une rivière qui est un affluent du Congo, dans le bassin du Congo, où, comme l'avait précisé ce matin lors des questions un intervenant, on travaille sur ce qu'on appelle des stations virtuelles, c'est-à-dire que c'est l'intersection entre la trace du satellite et une section de rivière, et sur laquelle on interprète les données qui ont été effectuées. Et donc, on a des séries temporelles. Planche suivante. Donc, quelques exemples d'utilisation de cette altimétrie radar sur les grands fleuves africains. Donc ici, c'est issu de 2 papiers, dont j'ai mis les citations en bas, et j'ai donné les références un peu plus loin pour les gens qui seront intéressés. Donc on voit qu'on a travaillé sur tous les grands bassins africains, sur lesquels on a traité l'ensemble des données altimétriques qu'on a pu traiter. Et ça nous a permis de construire des statistiques, des séries temporelles. On voit qu'on a, par exemple, sur la partie droite de cette planche, on a mesuré les amplitudes maximum de variation de niveau d'eau sur ces bassins, et c'est assez variable. On voit que ça peut aller jusqu'à 6-7 mètres de variation d'amplitude. Et donc ça a été fait de façon… ça a été publié pour interpréter ce résultat-là en termes de bilan hydrologique, de changement climatique, etc. Mais c'est également des produits qui sont distribués, et je vous expliquerai où un peu plus tard. Planche suivante. Et là, c'est la même chose, mais sur les lacs. Donc, c'est un papier qui vient de sortir là, dans Surveillance géophysique, sur lequel on a travaillé sur un certain nombre de grands lacs, et pas que des grands lacs d'ailleurs africains, et où on voit à travers ces séries temporelles qui sont beaucoup moins régulières que sur les rivières, parce qu'on a une variation interannuelle qui peut être très forte sur les lacs. Et on a fait des travaux, notamment récemment sur le lac Tanganyika ou sur le lac Tchad, qui montrent l'impact très fort des variations de précipitation sur les variations de niveau de ces lacs. Vous voyez notamment que dans les années 2019-2020, sur toute l'Afrique de l'Est, tous les lacs ont eu une hausse de niveau absolument spectaculaire. Et lorsqu'on voit des lacs comme le lac Tanganyika, alors là, il n'est pas mis sur cette figure, mais enfin, il a aussi une variation qui est très forte. Le lac Victoria ou le lac Turkana, qui sont des grands lacs, donc des grandes réserves d'eau, on voit une hausse absolument incroyable du niveau, qui a généré, bien entendu, des inondations, notamment dans la région nord du Tanganyika, dans des zones urbaines, liées à ces variations spectaculaires de niveau d'eau. Toutes ces données sont également entièrement accessibles et disponibles. Je vous dirai où après. Planche suivante. En fait, l'altimétrie satellitaire, donc, elle nous permet de faire beaucoup de choses. Là, je viens de vous montrer quelques petites illustrations sur l'Afrique. Sur le reste du monde, on fait la même chose. Mais elle a un certain nombre de limitations également. Elle a deux types de limitations aujourd'hui. On ne peut pas faire ça partout, parce qu'on ne peut pas couvrir l'ensemble de la Terre, ou plutôt on couvre l'ensemble de la Terre, mais pas avec une résolution intéressante, dans le sens où c'est une technique qui fonctionne, comme je l'ai dit, au nadir, Donc, entre deux traces satellites, on n'a pas de mesure. Donc, si vous avez un lac ou si vous avez des rivières qui vous intéressent, qui sont situées entre deux traces satellites, on n'a pas de mesure. Donc, l'échantillonnage spatial n'est pas absolument optimal, même si on peut faire beaucoup de choses. Et deuxième limitation, c'est qu'on peut pas le faire, on le fait pas tous les jours, puisqu'on est sur des orbites répétitives, comme je l'ai dit, mais pas des orbites répétitives journalières. Et on sait, à travers les discussions qu'on a avec les gens qui font de la modélisation, les hydrologues, les gens qui font du suivi, lorsqu'on veut faire de la prédiction d'inondations, de crues. J'ai vu aussi ce matin la présentation de la SICOS sur les questions autour de la navigabilité des fleuves. Il est évident que d'avoir une mesure que tous les 21 jours, ce n'est pas forcément optimal. Donc, on a ces deux types de limitations. Et étant donné ces deux types de limitations, les agences spatiales qui travaillent sur ces questions-là, donc la NASA, le CNES, l'ESA, l'ISRO, enfin, etc., réfléchissent à des missions, des concepts qui permettent de combler ces manques. Planche suivante. Donc alors Anaël, si vous pouvez juste cliquer en bas de la figure, enfin en bas de l'image, en bas à gauche, voilà, il y a une petite animation. Donc en fait, on a développé au Legos une idée qu'on a soumise au CNES et qui est à l'étude aujourd'hui et qui devrait voir le jour, d'une constellation de microsatellites, donc pas forcément avec une précision absolument extraordinaire, mais par contre, cette constellation permet d'avoir une revisite journalière. Et on voit là, donc sur des milliers de rivières à travers la Terre. Alors, en plus, si on va combiner ces données d'altimétrie avec des modèles type MGB, on va pouvoir aussi en déduire des débits. Et ce qu'on voit, c'est par exemple un exemple là sur la Garonne, donc la Garonne qui est située, qui passe à travers tout, qui traverse Toulouse. On a des données in situ, on a des données Jason 3 qui sont tous les 10 jours, donc c'est les petits points rouges, et on a fait un échantillonnage des données in situ à un jour. Et on voit bien que les inondations, enfin les crues qui peuvent apparaître subitement et qui sont importantes, on a de grandes chances de ne pas les observer par l'altimétrie actuelle, alors que si on avait un système avec des mesures journalières, on devrait être beaucoup plus proche de la réalité. Donc ça, c'est une mission qui, je le souhaite et je pense qu'on est en bonne voie, va être développée par le CNES et des partenaires privés et qui permettront justement d'avoir ces mesures-là. Planche suivante. Alors, le deuxième concept, alors celui-là, la mission a été lancée. Quand je me suis présenté, je n'ai pas dit, mais je suis le PI de cette mission. C'est la mission SWOT, donc Surface Water and Ocean Topography, qui est non plus de l'altimétrie radar classique, bien qu'il y ait également un altimètre radar sur le satellite, mais de l'interférométrie. Donc, cette fois-ci, au lieu d'avoir des mesures simplement on a des mesures de hauteur d'eau et également d'étendue d'eau. Donc, on mesure des contours d'eau par contraste d'énergie. On a des cartes, on va dire 2D, des hauteurs d'eau partout sur Terre, sur un grand nombre, enfin un nombre même très très important de lacs et de rivières, puisque les spécifications de la mission, c'est que on doit pouvoir mesurer tous les lacs qui font plus que 250 mètres par 250 mètres, en réalité plus que 100 mètres par 100 mètres, ça c'est un objectif, et toutes les rivières qui font plus que 100 mètres de large. Donc ça va nous permettre de calculer des stocks d'eau, des variations de stocks d'eau dans les lacs ou également dans les pleines inondations. Ça va nous permettre sur les rivières de mesurer, parce que sur les rivières, on va mesurer les hauteurs d'eau, on va mesurer les largeurs de rivières et on va mesurer les pentes des rivières. Et ça va nous permettre de mesurer, enfin de calculer plus que de mesurer, sur des tronçons ou des biefs de rivières de 10 km qui sont prédéfinis, les débits. Donc ça va nous permettre aussi de comprendre le rôle des rivières dans le cycle de l'eau, éventuellement de faire des applications beaucoup plus sur du temps réel, comme la prévision de crue, etc. Donc ça, c'est vraiment une mission. Alors la mission a été lancée avec succès au mois de décembre l'an dernier. On est encore en phase de calibration-validation, donc les résultats ne sont pas encore publiés, ne sont pas encore publics tout court. Par contre, les données seront diffusées normalement lorsque tout sera prêt au mois d'octobre ou novembre, on espère. Donc, planche suivante. Donc voilà, ça c'est juste une planche qui montre la couverture de SWOT. Alors là, vous avez une petite image qui montre sur un globe terrestre la couverture. Donc là, on n'est plus sur du nadir, on est vraiment sur de la fauchée. Donc une fauchée, ça veut dire qu'on couvre l'ensemble de la Terre. On a un petit exemple, par exemple, sur la France, où on voit vraiment que le gain en échantillonnage spatial qui est énorme. Et on voit également sur cette carte l'ensemble des lacs. Donc, si on se concentre sur l'Afrique, on devrait pouvoir mesurer les variations de niveau, de variations de stock d'eau également de plus de 76 000 lacs en Afrique. Planche suivante. Maintenant, pour les rivières.
Finissez bientôt. C'est très
Oui,
intéressant.
j'ai encore deux, trois planches, mais je vais aller vite. Donc, la planche suivante, c'est sur les rivières. Donc, sur les rivières, on va mesurer, j'ai dit, les débits. Donc, on va le calculer à partir des hauteurs d'eau et des largeurs des rivières, donc avec des produits qui seront diffusés. Donc, on a plus de 100 000 biefs de rivières qui sont prédéfinis. Planche suivante. Donc ça, je passe, c'est juste pour les gens qui vont télécharger la présentation, c'est l'accessibilité des données, que ce soit les données altimétriques, les données SWOT et un peu de bibliographie pour les gens qui sont intéressés. Planche suivante. Là, c'est ce qu'on a aujourd'hui d'accessible à travers le site HydroWeb, dont je pense pas mal de gens, enfin j'espère, sont familiers. Donc, on voit qu'on a des stations virtuelles et des lacs. On a plus de 24 000 stations virtuelles sur l'ensemble de la Terre. Et sur l'Afrique, là, vous voyez, j'ai pris quelques exemples sur le bassin du Congo, le bassin du Nil, le bassin du Niger. Vous voyez l'ensemble des séries temporelles qu'on est capable de mesurer, sachant qu'une grande partie sont mesurées en temps réel. C'est-à-dire qu'on a la mesure à peu près un jour et demi après qu'elle ait été faite par le satellite. Donc ça, il y a beaucoup d'applications en cours qui sont axés là-dessus. Et planche suivante qui doit être la dernière. Voilà, et ça, c'est juste un exemple. Je ne peux pas montrer encore de résultats SWOT parce que ce n'est pas encore validé, mais c'est juste une image qui a été prise de SWOT il y a au mois de janvier, là, après le lancement. Donc là, c'est une image qui est aux États-Unis, dans le New Jersey. On voit que l'ensemble des petites rivières, donc on a une rivière qui doit être la Connecticut peut-être, on voit que l'ensemble des affluents va être visible. Donc on a bien sûr les étendues, enfin la largeur de fleuve, mais là-dessus, sur toutes ces rivières, on va mesurer les débits. Donc c'est vraiment quelque chose de nouveau. Ça n'a jamais été fait par satellite précédemment. Et sur tous les petits lacs ou sur tout ce qui se passe dans le delta, on va également mesurer les stocks d'eau, les variations de niveau, les variations d'étendue. Donc c'est vraiment, alors c'est juste pour dire que, et je termine là-dessus, qu'avec SWOT, tout ce qu'on est en train de faire en ce moment nous amène vraiment à penser qu'on va avoir un jeu de données qui va vraiment révolutionner notre façon de considérer les mesures sur les grands bassins fluviaux. Voilà, j'ai terminé. Excusez-moi si j'ai pris quelques minutes de plus.
Mais c'était intéressant.
Merci beaucoup.
Merci beaucoup, Jean-François, en tout cas, pour cette présentation très didactique. J'en ai appris des choses. Et surtout, je note de bonnes perspectives avec SWOT et la disponibilité des données très bientôt, à partir du mois d'octobre, je pense.
Oui, oui, les données seront gratuites, complètement gratuites et accessibles à tout le monde, quoi.
C'est très bien. Donc, aux participants de bien noter toutes les références, les papiers dans cette présentation. Et surtout, posez vos questions dans le Q&A pour ça. Et avant de passer aux questions, je vais demander à ce qu'on nous donne la réponse à la dernière question posée. Merci beaucoup, Jean-François. So here are the results of the poll. Which hydrological products do you mostly use? People do use mostly rainfall products because they know more of it. It's been out for a long time. Oh, amazing. Altimetry products come after, followed by soil moisture, evapotranspiration. And the other one, the last one, is the use on numerical models or anything else. Thank you very much for that. Thank you all presenters for your very inspiring, very didactic, I would say. When I switch from French to English, I lose my words. Very informative presentation. Thank you all. So I will now open the floor for the questions. You have some of them have been already answered. The others, I will read them and see to whom they were. Quite a good number. I'll see what we can do. We are running late, but I think we can go 10 more minutes, isn't it? So the first one is from Hoda Saran Tuluka. She's asking, how can the ratio of soil moisture can affect the decision of cultivated land, the decision to cultivate the land? So I would ask you to be brief so that I can
I will be very short because actually I have already replied by text. And so basically it's almost has an impact on the water stress, and water stress is important for understanding the status of crop and vegetation, and to understand if we need to irrigate or probably change the type of crop. But I have also answered in my text.
Okay, so if you have already answered the question, no need to take the floor. Yeah, I'm going to read them because I don't know which one have been already answered. So the next one is to Luca. I don't know which one of the Luca. Are there specific tools to visualize? Are there specific tools to visualize the hydrological data?
Again, answered. If you go in the second box, you can find all the questions already answered.
Okay.
To save time.
Yeah. The third question, in French, quelle est la différence d'utiliser les données collectées en orbite basse par rapport à celles collectées en orbite haute? I don't know for whom is this question. Jesse, I didn't have anyone called Jesse. Somebody want to answer that question? It could be for you, Jean-François.
Oui, je pense que la plupart des satellites qu'on utilise sont des orbites, enfin en tout cas, bon, moi pour ce qui me concerne sur l'altimétrie, sont des orbites quasi polaires, situées entre 700 km et 1200, 1300. On est à peu près dans ces gammes-là. Pour différentes raisons, hein, pour l'échantillonnage spatial, également pour le rapport signal à bruit qui doit être suffisant. Donc, on est rarement sur des orbites très basses, de toute façon. Donc, voilà. Je ne sais pas si j'ai vraiment répondu à la question, mais voilà, les orbites sont vraiment choisies en fonction de ce qu'on cherche à échantillonner, aussi bien spatialement que temporellement. Donc ce qui compte pour nous, c'est l'intertrace. Si elle est large, l'intertrace, à ce moment-là, on a une répétitivité temporelle plus grande. Si elle est plus étroite, enfin, si l'intertrace est plus petite, on a une répétitivité temporelle qui est plus longue.
Merci. Une question pour Lucas encore, mais on ne précise pas lequel des Lucas, j'en ai deux. Alors, is there training on pre-processing and validation of the products from the hydrology SAF?
I think that my colleague Nicoletta Roberto could have better answered this question. I don't know if she's still online, but we are working in providing some training material about validation, and it will be available on the website.
Thank you.
In case training is, I mean, if you need some training, we can, I don't know, we can probably organize something, but we have to understand what is required.
Hello to everybody. I'm Nicoletta, and I'm working in HSAF, and we are going to provide a platform for training in AutoSelf about all kinds of HSAF products, and we are also working to provide some tools, for example, in Jupyter notebooks, or something else in open source tools to manage and to visualize data. We can also organize some specific training if we want to go in deep in some products or specific products for hydrology. So Luca Ciabatta give our contacts, and we can you can write us to organize some specific train. Thank you.
Thank you, Nicoletta, for offering this platform for training. And to participants, you have most of their addresses in the presentation that will be shared later on. And the last question is to Miguel. Is it to Miguel? Is
Yes.
Earth observation data effective for analyzing vapor pressure deficit at basin level? And do you have any example?
Well, this particular issue has not been part of what we have been investigating, but I think the material we have at this moment is pointing in the direction that yes, that the answer is yes. I don't have a particular example on that, but I think the evolution of the evapotranspiration algorithms, and given the fact that this vapor deficit is an important determinant, I think yes, we can. I can say yes.
The last question, and I will stop there because we are running over. Pour la prévision des risques d'inondation dans le lac, quelles sont les données nécessaires à collecter? C'est presque pour tout le monde. Peut-être Jean-François.
Oui, pour un lac, on a fait l'exercice récément sur le lac Tanganyika parce qu'il était intéressant. Déjà, il faut collecter en gros, pour savoir pourquoi il y avait ces inondations, on a travaillé sur le bassin versant. Sur le bassin versant, on a travaillé sur les données d'évapotranspiration et les données de précipitation. On a bien entendu corrélé ça avec des excès de précipitation quelques mois avant les variations de niveau du lac qui ont été observées, ce qui permet pas forcément de prédire parce qu'il y a beaucoup de facteurs en jeu, mais qui permet d'avoir une idée lorsqu'on a des très très fortes précipitations, ce qui était le cas sur toute l'Afrique de l'Est en 2019. On peut assez rapidement, comment dirais-je, en déduire que le niveau du lac va augmenter. Pour savoir vraiment la variation de hauteur du niveau du lac, il faut à ce moment-là, il faut également pour pouvoir voir les étendues, les inondations, avoir un MNT précis, donc un modèle numérique de terrain assez précis des zones côtières, puisque c'est ça qui va ensuite produire des inondations spatiales sur ces zones côtières. Donc, il faut des bonnes données de terrain, il faut des bonnes données de précipitation.
Okay, thank you so much. Thank you all presenters for your very informative presentation. I'm sure all of us have learned a lot. And thank you to all participants for staying with us, and to interpreters for the good interpretation. And to EUMETSAT, thank you for organizing it, and also not the interest of participants to have another webinar like that, and also share all presentation. So I'm handing the mic over to EUMETSAT. Thank you all.
Thank you very much, Marianne, for moderating this second session. And thank you again to the panelists, to attendees, to interpreters. We will send you an email with the link to access the presentation. If you want to have a look at it again, you will also be able to find the Q&A sessions, the Q&A chat with the answers. So we will get to you soon. Thank you again, and have a nice day.